Hello everyone. Welcome to Pakistan Polymer Research Forum. We are doing the second edition today, and this is a special event by TechnoBiz on polymer research in Pakistan. What kind of research is happening in Pakistan? So I welcome you all for this special event on Pakistan Polymer Research Forum today. Sawadee krap, namaskar. Let's get started. As you know, this is a TechnoBiz program. As TechnoBiz is based in Thailand, established in 2005, and it is recognized as International Resource Center for Industries and Technologies. Our key pillar for the TechnoBiz is the professional education and business and technical services. You can find a lot of information on TechnoBiz at technobiz.org, but you also need to follow me on my Facebooks or all the social media channels to get up-to-date information. When it comes to the services, we offer global services. We organize exhibitions, training, conferences, webinars, business networks, we have publications, we have networking events. We also have a talent search, knowledge test, technical consulting, skill development, marketing and branding, news server, and also the business buyer and seller meets. Again, is all connected to the knowledge side as well as the business services. When it comes to the focus, business focus, we cover two segments, and one on polymer industry, other is on the process technologies. When it comes to polymer industry, we address on the rubber industry, plastics, polyurethane, adhesive coatings, chemical and in process technology. We talk about chemical engineering technology, energy environment, filtration and separation, water and membranes, and also the advanced materials like nanotechnology as well. So this is our business focus. So just give you an idea what's all about TechnoBiz is, so that if you are looking for any specific information or specific service that you need, you can contact us, at TechnoBiz. I think most of you have my contact information because you register for this program. And one thing I'd like to introduce to all of you is the know-how webinars. We have, developed an online education platform, particularly for the professionals. There are lots of programs for the plastic industry, for the rubber industry, and also polyurethane adhesive coatings as well. So if you're interested in any of the training programs, check our website called knowhow-webinars.com. Okay. Let's get to today's. First of all, I need to thank Mr. Hamid Iftikhar. Actually, it's his vision, and he wants to promote. He wanted to indicate what's happening in research side, in the polymer research from the Pakistan. And we, TechnoBiz and Mr. Hamid Iftikhar, he joined together to organize this event. Without him, we're not able to put this program together today. And currently he's working as a senior manager at the compounding and tube division at Panther Tires. I welcome him to give a welcome remarks. Hamid, please.
Hello everyone, hope you all are fine, and thank you very much for introducing me, Aaron. This is the second edition of our Pakistan Polymer Research Forum, and I must thank first of all to Mr. Aaron for exchanging the introducing ideas of this forum with me, and definitely I took it on myself and put on my efforts and try to gather research persons from different universities, from different industries regarding polymer research in Pakistan. And, we had our maiden event last year that was quite successful, I must say. I mean, it was a maiden event, so there were a few hiccups in that, which we will try to cover up in this one and the upcoming ones in the coming months and years ahead. And today, 5 of our presenters, all 5 of those are from the different universities of Pakistan doing research on different topics regarding polymers. And I hope all of you will get benefit from their talk and in case of any other questions of yours, any other queries, any other, like you want to discuss something with the presenters who are well reputed professors in the different universities of Pakistan. You all are more than welcome for that, because the more we interact with each other, the more we learn. Because sharing is learning. If we keep our learning to ourselves, I think we cannot progress, we cannot grow. If we share our learning, if we share our research, if we share our expertise with others, definitely it will add more to our own knowledge. So this is what my theme is. I think without taking any more time of yours, let me ask Pam to start the presentation. Pam, please.
Thank you, Hamid. Really pleasure to to team up together with you and doing this program on regular basis. Okay, thanks a lot for giving a welcome remarks to the audience, guys. This is an agenda for today. We have all, as Mr. Hamid has mentioned, we have all together 5 specialized topics, and we have every speaker is experienced researcher, and they going to give what their research happening in their university, and also at the same time what their research, current research at their university. The idea of this program is not only listening to this presentation, but also that you expecting, if you have any questions, I encourage you to post your questions in the question box. We will have a discussion at the end of all the presentations. First, we will proceed with all the presentation one after other. After that, the Q&A session, or I call it a discussion, more of a discussion. We will be addressing all your questions at the end. The questions you can ask about questions based on what they presented, but also any general questions about the polymer research, because these gentlemen, all the speakers today, they're all well experienced researchers. I'm sure that they will be able to address or contribute in their own input into the questions you have. And more than that, if you're looking for a specific research, or if you're from industry, or you need some assistance from the universities, like from the University of Engineering and Technology or National Textile University, they have very useful facilities. I think it's important that you should know these researchers. You can collaborate with them, after the forum, or whenever you think that there is a need for cooperation between the university and your company. So this is an objective of this forum as well. It's not just only listening to the presentation, but we would like you guys to work together with these universities and the researchers to develop or to find a new solutions for your either industry problems or any research areas you have. Okay, so that's briefly. And again, please I'm encouraging you to post any of questions you have related to the polymers. Okay, address as we try to address as much as possible in the Q&A session. Okay, so let's get to the first presenter. Our first speaker is Mr. Hassan Iftikhar Ahmad. He is a lecturer at the National Textile University in Pakistan. He is going to present on the role of carbon black fillers on thermomechanical properties of carboxylated nitrile butadiene rubber, XNBR. So let's invite Mr. Hassan to make a presentation on this topic.
Good day, everyone. I welcome you all to the Pakistan Polymer Research Forum. I'm Hassan Iftikhar Ahmed, working at National Textile University as lecturer, and also I'm a PhD scholar at ComSAS University, working in rubber chemistry lab. My topic for today's presentation is role of carbon fillers on thermomechanical properties of carboxylated nitrile butadiene rubber. I'm thankful to Hamid Iftikhar from Panther Tires and Mr. Piram Prasada Rao from TechnoBiz for providing me this opportunity. So we are located in Pakistan in the city of textiles, Faisalabad, and we have a fully equipped National Center for Composite Materials. We are working in following areas: multi-layer 3D woven fabrics, woven composites, biocomposites, functional smart composites, auxetic composite materials, composite for protection, ballistics, and computational analysis. Our team consists of more than 10 to 15 members. This is our core team: Dr. Yasir Nawab, Dr. Tanveer Hussain, Rector, National Textile University, and Dr. Khubaib Shakir, HOD Materials Department, Dr. Umair, Director of National Center for Composite Materials, Dr. Ayub Askar, he is heading the ETRIC lab, and Dr. Talha Hamdani, he is looking after smart composites. So we have a fully equipped composite fabrication lab consisting of following machines: mechanical characterization lab, thermal characterization lab, and design and analysis lab. Coming to the presentation, the overview of the presentation is as follows. I will provide an introduction followed by the objective of this research. The experimentation conducted for this study will be presented. I will discuss the results, and then I will provide the concluding remarks. So this research implies carbon fillers for improved mechanical performance of rubber, and this research has potential applications in rubber industry, aerospace, blast-proof curtains, ballistic panels, automotive, and armor solution for vehicle protection. A thermomechanical testing has been done of three different rubber hardness of Shore A 61, 69, and 74. Falling tests are performed: tensile, Charpy, low velocity drop weight impact, dilatometer, and thermomechanical analyzer tests are performed according to the standards. So different fillers can be used to impart different property to the rubber. Like carbon fillers can be used to impart mechanical, electrical, and thermal properties. Inorganic fillers, which are cheaper as compared to the carbon nanotubes and graphene, which are quite expensive. And similarly, biofillers can be used, which impart mechanical property to the rubber. And these are the physical properties mentioned for different fillers. For our current research, we have used carbon filler to impart mechanical property to the rubber. Carbon black is available in variety of grades, and so they impart abrasion property, mechanical property, and functional properties to the rubber. And there are different processing techniques, and adding some fillers can impart fast extrusion and good abrasion property to the rubber. The objective of the research is as follows: to study the thermomechanical performance of rubber by addition of carbon fillers. We used carboxylated nitrile butadiene rubber for our research. It has good toughness property, and it is highly polar in nature and oil resistant rubber. And this is the mastication of the rubber, which is done in open to roll mill at the industry. So for the experiments, we chose high extrusion furnace carbon filler and high abrasion furnace carbon filler in equal proportions, and they were blended with carboxylated nitrile butadiene rubber in open roll mill. And we performed tensile test at three different strain rate, and as you know that rubber is viscoelastic in nature. And similarly, we performed curing test, drop weight test, dilatometer test, and Charpy test for mechanical characterization. This is one grade of rubber N330, which is a furnace black rubber, and it imparts high abrasion property to the rubber, and which is high resilience and impart good tensile strength properties to the rubber. So these are the recommended applications where this type of filler can be used. We used another type of filler, which is N550. It is a fast extrusion furnace rubber which provide moderate resilience, and it imparts very good mechanical properties. So this is the formulations of carboxylated nitrile butadiene rubber mixed in three different proportions. At the first stage, rubber was masticated and then carbon fillers were added. So we choose equal proportions of N330 rubber and N550 rubber, and PHR of 20, 25 and 35. And then we used MBT, MBTS as accelerators. We used TMQ as anti-aging agent, Stenoflex as antioxidant, zinc oxide as activator, stearic acid as plasticizer, and sulfur as vulcanizing agent. So in general, the vulcanization of rubber comes in 3 to 4 steps. Rubber mastication is done for approximately 15 to 20 minutes, and then activator, plasticizer, anti-aging agent and fillers are added. In the third stage, accelerator is added, and in the last stage, sulfur is added for vulcanization of the rubber. So these are the curing characteristics of the XNBR blend which was prepared of the three samples. And the table shows that with the addition of higher concentrations of carbon fillers, the higher minimum and maximum torque values are achieved. The results show that scratch time and optimum time is reduced with the addition of carbon fillers, indicating a strong interaction between the fillers and the rubber. This is also linked to the viscosity of the compound, suggesting an increase in the viscosity and hardness with the addition of carbon fillers. So the torque time is increasing with the increasing of the hardness, and the scratch time is reducing with the increasing in the hardness of the rubber. So these are the tensile tests which were performed at three different strain rates of 100 millimeter per second, 200 millimeter per second, and 300 millimeter per second. And we can see that with the introduction of carbon filler in the XNBR compounds lead to a higher tensile behavior and show a stiffening effect due to the addition of higher contents of carbon nanotubes and the interfacial interaction between the carbon fillers and the rubber matrix. So this figure shows the tensile strength of fabricated XNBR rubber samples. So the sample with the highest hardness, which is sample D3, shows the 165% increase in the tensile strength with the addition of the carbon fillers. So this is the results of the elongation and break of fabricated XNBR rubber samples. So there is some reduction in the elongation at break with higher concentration of carbon black fillers as shown in the figure due to some resistance in chain mobility of polymer matrix induced by the incorporation of the nanofillers. This figure shows the modulus of fabricated XNBR rubber samples at 200% elongation. So this figure shows that the introduction of carbon fillers into the XNBR matrix leads to an increase in the modulus at 200% elongation, which is attributed to the dispersion state of nanotubes and their interaction with the polymer matrix. So This figure shows the results of the Charpy impact test of unknown samples of vulcanized XNBR. And this figure shows two peaks. The first peak shows the peak impact force, and after this peak the sample lose contact with the pendulum, and thereafter a second peak force is observed in case of all tests. The sample D3 with the highest hardness show the highest energy absorption peak, and with the reduction in hardness the peaks are also reduced. So these are the results of from the drop weight test force vs displacement of vulcanized XNBR at 10 joule energy levels. So as you can see, the sample is rebounding back at different stages, and several peaks are observed. So there is no damage to the samples, and just a depression is formed on the rubber. And the sample with the highest hardness shows the highest energy absorption peak. This is the picture of the thermomechanical analyzer. So thermomechanical analyzer is a test which is performed at different temperature range, and the dimensional change is measured. So the this test can be performed in the tension mode, expansion mode, and penetration mode. So in our study, we have performed this test in the expansion mode. So these are the dimensional change vs temperature curves obtained using the thermomechanical analyzer in the expansion mode for the vulcanized XNBR rubber. So the results show that rubber with highest hardness show more resistance to penetration, hence less dimensional change. The trend is followed by the rubber showing less hardness, D2 and D1 as compared to 3D3. The coefficient of thermal expansion is determined by calculating the slope of the curve, and the coefficient of thermal expansion is nearly constant for all the rubbers. Similarly, dilatometer tests were performed. The samples of three different hardness were placed in the dilatometer in a furnace, and the dimensional change was observed with the change in temperature. So these are the results of dimensional change with temperature curves using dilatometer of various formulations of vulcanized XNBR. We change the temperature from 30 to 100 degrees Celsius, and from the figure it is clear that with high carbon filler loading there is a more dimensional change as compared to the samples with less carbon filler loadings, as in the case of sample D1 and D2. The sample D3 depicts a stiffening effect and is rigid as compared to D1 and D2, whereas the samples which are flexible and slack structure show less dimensional change. The linear expansion coefficient of rubber with highest hardness is high as compared to the samples with lowest hardness. So in this slide, I will be providing the concluding remarks. So the result from the Cure rheometer show that with the introduction of carbon fillers into the XNBR cause a rise in the maximum torque while slightly decreasing the scratch and optimum cure times. The tensile strength and modulus at 200% elongation increases with the higher carbon filler loadings, while there is a slight decrease in the value of elongation at break. The effect of strain rate on the modulus and tensile strength show a slight increase in these properties. The increase in the carbon filler contents increase the mechanical performance of rubber and hardness, and the XNBR with 35 PHR filler content show the maximum hardness value of 74. The chart pie impact test and drop weight impact test show that the samples with higher filler content show the maximum energy absorption and impact property of the samples. The dimensional change properties using the expansion probe suggest the sample with high hardness and carbon filling loadings show least change and resistance to penetration. The dilatometer test suggests that sample with higher filler loadings show high dimensional change due to the stiff nature of the samples. So the hardness of the sample and has a major role in the mechanical performance of the rubber. So the samples with the high hardness show good dimensional change during a dilatometer test and show good energy absorption as compared to sample with low hardness. Thank you everyone for listening to my talk. I can be reached through the following email address and WhatsApp number if you have any more questions. I'm again thankful to Mr. Piram Prasad Rao and Hamid Iftikhar from Panther Tires for providing me this opportunity. So if you have questions, I'm looking forward to answer you all. Thank you.
Okay, that's a very good presentation on the role of carbon black fillers on thermomechanical properties of the XNBR. Thank you, Mr. Hassan, for excellent presentation. Guys, as Mr. Hassan has mentioned, about any questions you have, you can post them in a question box. We will address these questions in the discussion session at the end of all the presentation. When you write the questions, please mention the speaker name, speaker name, or attention speaker name, so that we know whom to address these questions. Okay. Let's move to the next presentation. The next presentation is on the economical polymer nanocomposites as the conductive and insulating plastic products for electronic industry. We have Dr. Asir Khayyamgil. He is an assistant professor at the University of Engineering and Technology, Lahore, this in Pakistan. So, Dr. Asir, over to you. Asir, can you unmute yourself, please? Can you unmute? Oops. Okay. Again, yeah, go ahead.
Hello, everyone. My name is Dr. Yasir Khayyamgil. I'm an assistant professor and semester coordinator in the Department of Polymer and Process Engineering, University of Engineering and Technology, Lahore. I would like to first of all thanks Mr. Hamid Iftikhar and Mr. Piram for giving me this opportunity to present my research, which I'm doing in Department of Polymer and Process Engineering. My topic of presentation today is economical polymer nanocomposites as conductive and insulating plastic products for the electronic industry. With regards to the presentation overview, I'm going to start off with.
Yes, sorry to interrupt you. Can you put in the presentation mode? Proceed.
Okay. I'm going to start off with the introduction, and then we will talk about the future of polymers in electronic industry. Then we'll talk about the role of testing and characterization of polymers. And then later on, there will be two case studies with regards to the electrically conductive polymer composites, and the electrically insulative polymer composites. And finally, there will be the conclusion. Now, with regards to introduction, electrically conductive polymer composites are class of materials that have either conductive fillers or conductive polymers that are dispersed within another polymer matrix. Now, in the recent years, conductive polymer composites have gained quite a lot of attention due to their wide range of application, and this has been achieved due to the low density, ease of processability, corrosion resistance nature, tunable electrical properties. These electrically conductive polymers are widely used in sensors, self-regulated heating materials, energy storage areas. So these are all the regions in which polymer composites that are either conductive or on the other end that are insulative. They are finding quite a lot of application. The insulative polymers are actually used in wire coating throughout the world. Every one of us have used these electronic wires on a daily basis. So polymers are being used quite a lot in the electronic industry, whether in specialized area or whether in the commodity areas. Now, some of the most famous polymers that are being used at the moment include your polypropylene, polyethylene, or PVC or polypropylene tandem copolymer, or there are special polystyrene, polyamides, or specialized polymers or engineering grade polymers such as ultra high molecular weight polyethylene. Now, in order to improve the conductivity of these insulative polymers, we try to add certain conductive fillers and conductive polymers in them. A conductive polymer is basically an organic polymer that has certain characteristics which make it to behave as a semiconductor or a conductor. These include polyaniline, polypyroles, polythiophene, polyphenylvenylenes. These are few of the most widely used conductive polymers throughout the world that we use on a daily basis. Now, moving ahead, there are other areas in which polymers are also used in the electronic industry, and one of the most famous one is your polymer, where polymers are used because of their insulating properties. Now, in that area too, we can utilize certain nanofillers such as cyanide silica can be incorporated to improve its insulating properties. Now, moving ahead, everyone at the moment would ask the question that why we need to modify the polymers that are already being utilized and are very successful in the past 50 years so that the electronic industry can utilize them more effectively. That has come from the basically come from the fact that at the moment electronic industry is generating tons of plastic waste throughout the world. That has caused a huge uproar throughout the world where people are now demanding that less and less of plastic should be used in the various applications, whether they are automotive, whether they are electronic, whether they are packaging. These are few of the products that we use on a daily basis. So the same sort of effect is being felt by the electronic industry. Now, just looking at the slide, you can see on the left-hand side all the plastic waste that ends up along with the electronic waste in our various dumps. And on the other hand, companies throughout the world are now trying to rectify this problem by introducing the concept of closed loop recycling. That is based upon the fact that the companies are now trying to collect the products that they have introduced into the market and then trying to reutilize them. For example, in this slide, you can see Dell has a monitor, an Optiplex 3030, in which they have actually used the plastic collected from the take back and recycling programs that they are conducting for the world, and it goes through the normal closed loop recycling scheme where it is sorted out, cleaned out, separated out from the metals, and then it is crushed, and finally it goes into an injection molding machine for it to be converted into plastic products. Now, this sort of a option is now being adopted by quite a lot of companies throughout the world, and within Pakistan we also need to make sure that our companies are in line with these options that are available to other companies throughout the world. In Pakistan at the moment, most of the plastic that we collect, it ends up into the food chain, food-based packaging chain, because those are commodity products. So everybody wants to manufacture plastic products that are commodity in nature and that can sell very quickly. Plastic products, on the other hand, that are used in the electronic industry are not commodity, and they require quite a lot of time before you can get huge profit margins out of them. But due to the various restrictions at the UN level in March this year, a huge consortium was arranged by the UN, in which different countries and different companies came together to make a pact so that they can reduce the amount of plastic. And along with that, they also pledge that they will reduce the amount of plastic that they are going to use in their products. Along with that, they are going to make sure that their products are ready to recycle, and along with that, they are going to ensure that the plastic products that they would introduce into the atmosphere would then be collected back. So in order to make sure this, we at this department are now working in this area, and we are not only restricted towards a single waste. We are saying that, okay, we should combine the different wastes that are being introduced into the atmosphere. These include your electronic plastic waste, your single-use plastic waste, your hospital waste, and your automotive plastic waste. All of these can be sorted out, separated out, and depending upon their contamination level, they can be reintroduced into your final products. Every plastic should be reused. This is what our concept is. It should be recycled, or if not possible through recycled, it should be upcycled into a high value item. And taking into account this fact, we are very much confident that this path can only be taken where we are going to develop the recycled or upcycled product if we can comprehend the overall properties of the plastic, and that can only come by understanding the testing and characterization of polymers. The testing and characterization of polymer takes into account the chemical characterization, thermal characterization, mechanical characterization, morphological characterization, electrical, rheological, and barrier characterization. A thorough understanding of all of these characterization will only enable the recyclers or the manufacturers to develop products that can then be collected back and be converted into useful products that are going to be utilized by the various vendors throughout the world, whether they are in the automotive sector or whether they are in the electronic sector, or even if they are in the food packaging sector. Now, we at the Department of Polymer and Process Engineering have quite a lot of facilities that can be utilized by the researchers who are listening at the moment. Just to give you an introduction, we have, in terms of rheological characterization, we have a melt flow indexer, we have a moving diameter, a Brookfield diometer, and a Prabender plastic coater is available that can be utilized to study the rheological behavior of the polymer once they are exposed to high temperature and high strain rate condition. In terms of mechanical characterization, we have a dynamic mechanical thermal analyzer along with the ISO and Charpy tester and a universal testing machine for tensile testing or for compression testing. Along with that, for impact testing, we also have a tubular impact tester. In terms of thermal characterization, we have a differential scanning calorimeter. HGT Vicat can be used. Once again, the DMTA that I showed you in the previous slide can also be used for the thermomechanical analysis. A TGA is available, thermogravimetric analyzer. Along with that, we have a range of aging oven, and along with that, drying oven and furnaces that are available in our department to carry out the overall thermal behavior of the plastics, along with various elastomers. Now, moving ahead, why we need to utilize those techniques? Because if we are able to utilize those techniques, then we can develop strategies. At the moment, the world is at a point where the world needs very clear-cut strategies. At the UN level, all countries basically agreed to a fact that there will be one strategy or one law for all of the countries. It wouldn't vary from region to region. So as a result of which, the whole countries can move in a similar direction. There are no various directions that, okay, we can send our waste to China or Malaysia and then they can process it. No, all the countries need to develop a single strategy, and then based upon that strategy, we can then develop solutions. Otherwise, I've been working with the Environmental Protection Department for the last 4 years. It becomes really difficult if your strategies are not developed effectively. Now, just talking about the various steps that are involved in the recycling of single-use plastics, these include your plastic waste collection, sorting, washing, crushing, drying, extrusion, pelleting. Finally, we get the recycled product. Now, this is a simple strategy based upon which the single-use plastics can be collected from the market, and then they can be recycled on a daily basis very effectively. But one of the problem with these products is that their collection. For that,
We have lost connection with Dr. Esser. Please stand by. Please stand by. Please stand by. Dr. Esser?
yes, I
Okay.
think there was a
Yeah, interruption. Okay, you can start with this slide, please. Go ahead.
okay. Let me just start again with the discussion on the waste strategies for waste collection.
Full screen, please. Full
Yes,
screen,
yes,
please.
I'm doing that. I'm doing that. Wait. Okay, so the waste strategy for collection in Pakistan would depend upon dividing our waste into household waste, industrial waste, dumping sites, and recreational sites. And for each one of them, developing a different strategy. For example, for houses, we can have the color-coded bags, bins, or chambered bins. For industrial waste, we need to form waste management teams, worker training for segregation, and scheduling containers for recycling. In terms of dumping side, we can have the utilization of waste sorting technologies at them to convert our waste into recyclable and non-recyclable waste. For the recreational sites, we can also provide bins, have free bin services and free duty of care certificates, so that they can be so that the vendors at recreational site can be and encouraged to work more towards our waste collection. If we are able to achieve that, it will all contribute towards waste source from which energy can be recovered, or it can be utilized for the development of upcycled polymer. If not, all of them would have to then face heavy fines. Now, based upon this work, we have also developed a case study in which we developed a waste management strategy for Pakistan that is based upon hospital plastic waste. And we have published this in the Journal of Environmental Science and Pollution Research. We all know that a lot of plastic gets used in the hospitals. That includes your polyethylene, polystyrene, PVC, polypropylene. These are a few of the major polymers that are used. Apart from that, polyamides, polyester, polycarbonate, polyurethane, these are a few of the other engineering plastics and the high temperature polymers such as polyamides, polyethylamides, polysulfones are also used in plastics in 10 to 20%. Whereas on the other hand, the 70% plastic used comes from the commodity plastics. Unfortunately, in Pakistan and in Asia, it ends up either in landfills or at waste sites, and most of it, even if it is collected, that then gets converted into these cheap plastic products that we either use in as straws or as various containers. So in order to discourage that, we need to look at a strategy. So in order to make sure that we are able to do that, first of all, we gave some suggestion that can be based upon already implemented strategy in UK, where they actually divide the recycling cost. Okay, what they say is that the raw material manufacturer should contribute 6%, converter should contribute 11%, and the packer or filler should contribute 36%, whereas the retailer should contribute 47%. So in this case, we can ask the hospitals that they should contribute 47% of the plastic waste cost, and the rest of the cost will come from the supply chain. In this way, we can then go towards the hospital and ask them to be much more vigilant when it comes to the hospital plastic waste. In USA, segregation of the plastic is done by the client. It is not the responsibility of the government, but actually the client or the hospitals or the health clinics, medical camps, animal hospital, they are all responsible for sorting out the segregation by themselves. So in this way, for the legislation for the recovery of hospital plastic waste and the legislation for the segregation of hospital plastic waste can then be developed. And based upon then, we can go toward the hospital and then ask them to do the sorting out. After they have done the sorting out, we can then develop a research that should be focused on the chemical cross-linking disposal method, because this is one of the most effective methods when it comes to hospital plastic waste, because we want to discourage the utilization of hospital plastic waste. So if we are able to do that, then we can have good products that can then be utilized in the pyrolysis or incineration area. So there are various methods that can be adopted. These include the cross-linking method of LDP and wax blends. We can prepare the cross-linkable high-density polyethylene and polypropylene blends. We can also study the effect of peroxides, and based upon that, a review summary of the various methods that are already adopted by the industry for cross-linking of plastic is shown to you over here, and a process flow diagram that we suggested, in which we collect the plastic waste from the hospital, crush it down, mix it with the cross-linker, thermally compress it, and then finally we move it into a crusher again and through the incineration. In this way, if anybody wants to collect this plastic, they won't be able to reuse it, because the cross-linking would discourage the thermal processing. An overview of the hospital plastic waste management would then consist of segregation, collection, transportation, treatment, and final disposal. Now, where can we use such cross-linked products in the electronic industry? So in terms of the electrically insulative polymer products, we did a research in the Department of Polymer and Process Engineering, which was basically carried out by my MSc student, Ms. Hira Ehsan, and then we published it in Polymer Bulletin. And the title of the consisted of a novel two-step melt blending method to prepare nanosalinized silica reinforced cross-linked polyethylene nanocomposites. We developed a technique, a melt processing technique, in which the raw material were first of all fed into the internal mixer, then into hydraulic press, then through a molded, with the help of molded thin films, we were able to develop these powdered specimens that were then physically mixed with GCP, and later on these were compression molded, and finally we were able to develop the compression molding sheet. The ratios and the SCM surfaces, which shows no presence of any agglomerate formation, are shown to you in this slide. The thermal properties, the densities, the breakdown strength, the solvent uptake, and the flammability showed that with the inclusion of silicon silica, we were able to develop electrically insulated products with enhanced properties. And a slide over here shows you the overall data in terms of the viable percentile, the solvent uptake, the density, and the breakdown strength. Also, UV degradation analysis of the samples were carried out, and the overall results showed that the incorporation of filler resulted in formation of networking domain between nano-silanized silica and polymer matrix. Silane group, which were coated onto the silanized silica, gave better compatibilization that result in better resistance to UV degradation, so your product can be utilized for a longer period of time. Another area where the recycled polymer can be used in the electrical industry is to develop electrically conductive polymer composites. In this area, one of my undergrad students, Mr. Friedul Haq, along with the different members, and especially I would like to mention Professor Dr. Abdul Shakur from the Department of Mechanical Engineering, who worked with us to develop carbon black nickel hybrid fillers that are economical in nature as compared to the comparative expensive nanocomposites based products that are developed using graphene fillers or multi-wall carbon nanotube. So in this research, we were also able to develop first of all, a processing technique that is overall economic in nature and can give you enhanced properties with very few formation of agglomerates at very high weight fraction. FTIR and tensile strength measurements were carried out, and they showed improvement of properties at 2 weight percentage of filler addition, and later on a decline in the properties was experienced. But on the other hand, once we carried out the electrical conductivity of measure the electrical conductivity of the composites, and it is plotted over here as a fraction or a function of the filler loading, it showed that an enhancement in the electrical conductivity was observed due to the presence of this electrical conductivity path, which was generated by utilizing different shaped filler. We have the carbon black particles that are available along with the platy nature of the nickel flakes, which through the help of which we were able to develop the conductivity path within the composites, and based upon that we were able to use these composites. Another case study that we have done is the synergistic augmentation of polypropylene composites by hybrid morphology polyaniline particles for anti-static packaging application. In this area, once again, we utilized our developed polymer processing technique of ultrasonication, and based upon that, we were able to develop composites that showed very good characteristics. Now, in this slide, you can see the prepared powder, and along with the prepared powder, the polypropylene and polyaniline specimen before and after processing are shown to you over here, that they retain their green color, and the coating of the polyaniline on the surface of polypropylene is shown in this slide at the bottom, where the presence of green color ensured us uniform coating by the technique that we have developed. But once again, through SEM, we were able to generate the result at very high weight fraction. We were able to see some of the agglomeration, but generally speaking, we get good dispersion and distribution, and once again, it led towards the formation of enhanced conductivity in our product. Now, concluding the discussion that we had today, first of all, we need to develop a polymer waste strategy that is linked with the utilization of waste in the automotive and in the electronic industry, and also in some areas of commodity plastic products. If we're able to develop that strategy, then we can utilize this waste in the electronic applications where they're going to stay for a longer period of time, and there will be no direct contact with humans. At the moment, companies are looking to develop products that are used, unfortunately, for food packaging from plastic waste. Here, you can use the waste, but you can't use the waste directly in the food contact layer, because from the food contact layer, leaching or blooming can cause the transfer of particles or waste into your food. So we need to develop a strategy in which waste is used in electronic applications, in automotive applications. So in order to do that, a linkage between academia and industry is needed. At the moment, we have just won a PSF Pakistan Science Foundation funding, with the help of which we are going to develop polymer nanocomposites for the automotive and electronic industry. Industries are on board with us. Grand Engineering, which is a manufacturer of automotive parts, is working with us to take ahead this concept, and they are already working with us in this PSF and on another project, hopefully in the future with HEC. So in the next level, after we have developed this strategy, then we need to take it with the government that, okay, government needs to collaborate with industry so that they can standardize the whole thing. And finally, with the help of this work, we can then develop the Pakistan Polymer Pact, in which we can ask the industries to pledge that they would make sure that all of their plastic is reused in applications where direct human contact is to a minimum, especially when it comes to our food. And along with that, they can reduce the amount of plastic that they are already using, and they can develop their own life cycle analysis or closed loop recycling techniques. So with that, I would like to conclude my presentation. If you have any questions, you can ask at the end. Once again, I would like to thank Mr. Hamid Iftikhar and Mr. Piram for giving me this opportunity.
Thank you very much, Dr. Asir. It's a very interesting presentation on the plastic waste and the issues related to the electronic and automotive industry, particularly with reference to the nanocomposites. Guys, if you have any questions, you can post the questions in the question box. We will address the questions at the end of all the presentation. Okay. Once again, thank you, Dr. Asir.
Thank you, Piram.
Let's move to the next presentation. Next presentation is focusing on the role of commercial and economical nanofillers in plastic compounds for automotive industry. This presentation will be given by Dr. Farhan Saeed. He is an associate professor at the University of Engineering and Technology in Lahore. So let's welcome Dr. Farhan.
Hello everyone, I'm Dr. Farhan Saeed, working as Associate Professor in the Department of Polymer and Process Engineering, University of Engineering and Technology, Lahore, Pakistan. Today's my talk is on the role of commercial and economical nanofillers in the plastic compounds for automotive industry. In today's talk, I will discuss about the classification of fillers in local automotive industry, the particle size of fillers and their effect, the presence of the active sites on the surface of the fillers, the effect of the fillers on the mechanical performance of the different automotive parts, and at the end I will conclude my presentation with the ending note. We mainly classify the fillers based on their performance, for example, reinforcing fillers and the non-reinforcing fillers. But in our local Pakistani industry, the fillers, they are classified based on the color. So that's why we can classify the fillers into two different categories. One is the black filler, second one is the non-black filler. In black filler, we mainly use the carbon black as our main filler. There are different grades of carbon black which we can use. In non-black fillers, there are various particulate-like materials, just like calcium carbonate, silica, talc, and precipitated silicates, which we can use. And there are some plate-like materials, just like the kaolin clays, which can be used as the non-black filler in manufacturing of different automotive parts. So the broader classification of filler based on the color doesn't restrict the automotive parts manufacturer on the one category of the filler. They can have the hybrid filler as well. They can use the combination of the black and the non-black filler. Mainly black filler, they are used in those parts where we need the black color. Apart from the black color, we can go for the non-black fillers. And if we use the hybrid fillers or combination of both black and non-black, definitely our compound color would be the black. So in our industry, mainly we classify our fillers based on the colors rather than their performance or their reinforcing mechanism. There are different factors which affect the activity of the fillers, which include the particle size, particle surface area, particle shape, particle surface activity. Although these factors, they are very important in the selection of fillers for different uh, parts, for different applications. The particle size is very important because there are different type of fillers available in our market, which are in the micron sizes or which are in the nano sizes. Just like three main fillers in our industry, the calcium carbonate, carbon black, and silica. Out of these three fillers, the calcium carbonate, that is mainly present in the micron sizes, whereas the silica and carbon black, they can be present in the nano sizes. The particle surface area, that is very important in terms of the reinforcement of the filler. Better the surface area, better would be the reinforcement of the filler with our polymer. The surface area can be enhanced by different methods, by different surface treatment methods, which are available for different kind of the fillers. Then particle shape is also very important criteria, because there are different fillers which are present in the particulate-like nature. There are different fillers which are present in the plate-like nature, just like calcium carbonate, carbon black, and the silica. They are particulate fillers. Their shape is the spherical, whereas the kaolin clays, they are present in the plate-like structure. And particle surface activity is also very important in the sense, because there are different type of the active groups present on the surface of the filler, and those active groups, they interact with each other, or they interact with the polymer chains. By this interaction, they create the reinforcement mechanism, or they make the aggregate and agglomerate of the fillers, which are present in different compounds. Then we will first talk about the particle size, which is available. Particle size of the filler is very important in terms of the selection of the filler for different applications. We have the different classification of the filler, just like the non-reinforcing, semi-reinforcing, and the reinforcing filler. Mostly this classification, they are based on the size of the filler. The fillers which are in the nanometer sizes from 0 to 100 nanometer, they are mainly classified as the reinforcing filler, and silica and the carbon black, they are the two main fillers which are used in our local automotive industry as the nano fillers, whereas the precipitated calcium carbonate and the clay, kaolin clays, they are the semi-reinforcing filler which are used in our local automotive part manufacturing industry. There are few fillers which are dry grounded calcium carbonate or the talc. They are having the particle size greater than the few microns, and they are mostly classified as the non-reinforcing filler. If we talk about the nanofillers, the precipitated silica and the fumed silica, they are the main reinforcing filler in our industry. Carbon black is also widely used, mainly for the black parts. There are different grades of the carbon black, mainly N110, N220, N330. They are the ranges which comes under the reinforcing category, which are in the nanometer sizes. The grades which are having the high structure, they comes under the semi-reinforcing category. After the particle size, the surface area is another criteria which is important for the selection of the filler. Mainly, for reinforcement, we need the high surface area. And definitely for high surface area, if we reduce the particle size, we move towards the high surface area. But if we by reducing the particle size we can't get the high surface area, uh, then the surface area of the fillers, it can be enhanced by different surface treatment methods. uh, for example, we can enhance the surface activity of the carbon black by putting them in the furnace or in the oven at the high temperature. So the surface area of the carbon black will increase after some time when we expose them to at the high temperatures. Similarly, the surface area of the silica and the other particles that can be enhanced by different treatment methods. We can also coat different chemicals on the surface of the fillers as well. Then the active sites on the which are present on the surfaces of the different fillers, they are very important. Due to those active sites, sometimes different fillers, they can interact with each other to make the aggregate and the agglomerate of the fillers. And when we compound those, we make the compounds using those fillers having the aggregates and agglomerates. It's difficult to disperse those fillers in the plastic and in the elastomers. So we need a very high shear to disperse them in the polymers. Mainly the presence of the aggregates and the agglomerates, that is due to the presence of the active sites on the surface of the filler particles. Just like for carbon black, or you can see here, there are different particles of the carbon black which are linked with each other to make an aggregate, and different aggregates, they can link with each other to make the agglomerate. And the interaction of one particle with the other particle, that is due to the presence of different active sites. In carbon black, we can have the hydroxyl group, we can have the carbonyl group, we can have the hydroquinone group, and presence of the different polyaromatic sites on the surface of the carbon. And that is due to the byproducts which are formed during the manufacturing of the carbon black. So if we use these active sites during the compounding of the different polymers, you can see here, I take the example of the carbon black. And when carbon black, that is mixed with the different polymer chain, and the presence of these functional group or active sites, they interact with the chains of the polymers. And when they interact with the chain of the polymers, it will have the better interaction with the filler and the substrate, or filler and the polymer. So it would give you the better mechanical properties by reinforcement mechanism of filler and the polymer. So the presence of the active sites, on the one side, it makes the aggregates and agglomerates of different particles, whereas on the other side, the presence of active site, that is important for the interaction with the polymer chains as well. So if we have better interaction of filler with the polymer chains, mean we have the better reinforcement, and if we have better reinforcement, mean we will have the better mechanical properties of the polymer compounds. So the active sites, they play a major role for during the compounding of the filler with the different polymers, because on the other side, one side, we need the high shear for the to disperse the filler in the polymer. On the other side, they would give us the better mechanical performance by reinforcement mechanism. Similarly, in the silica, we also have some active sites which are present on the surface of the silica. We do have some hydroxyl group, presence of the hydroxyl group on the surface of the silica, and we do have some silanol group present on the surface of the silica. And in fact, the presence of the hydroxyl group, that is very tricky in the sense because hydroxyl group they can make the hydrogen bonding, they can interact with each other to make the hydrogen bonding, and due to this hydrogen bonding we do have more interaction of one particle with another particle, and due to that interaction of one particle with another particle it makes uh, it converts different particles into the aggregates and agglomerates, just like you can see here. The silica particles, they can convert it into the aggregates and agglomerates, and that is due to the presence of those active sites on the surface of silica. Uh, and hydroxyl site, that is the more interacting site because it can provide the hydrogen bonding, and the physical interaction hydrogen bonding is the more active bonding or interacting site, which due to which would be more formation of the aggregates and agglomerates. If I compare the silica with the carbon black, so I can say there will be more hydroxyl group on the surface of the silica as compared to carbon black. So the tendency of making the aggregates and agglomerates in the silica would be more as compared to the carbon black, because carbon silica is having the more active sites and the more interacting sites as compared to the carbon black. But it doesn't mean that the silica if it has the aggregates and the agglomerates, it cannot be dispersed. The dispersion can also be enhanced by increasing different dispersing agents, just like we can use the different glycols which help us to disperse the silica and the in the different polymers. But just only dispersion is not the main requirement, because sometime if we disperse the silica in the polymer and we get the better dispersion, still we can't get the better reinforcement because most of the sites they are filled with the hydroxyl group, and the presence of those hydroxyl group makes the silica inactive. So silica would not give you the better reinforcing property, and that is the main factor, because due to which silica could not be used for the as reinforcement for a longer period of time. But nowadays we do have the some treatment mechanism available. We have the different type of the silanes present, which can interact with the hydroxyl group and which can make it non-polar, or which can make it more interacting with the polymer chain. So when we talk about the presence of the active sites, so in silica the active sites that is more detrimental as compared to the carbon black, and presence of the active sites of just like the silanol or the hydroxyl group on the surface of silica would uh, uh, would actually restrict the silica from the reinforcement mechanism. So unless we remove these active sites or we overcome these active sites, we can't get the better reinforcement in the silica. So to have the better interaction in the silica compounds, what we have to do, we have to treat the surface of the silica with the different uh, we have to treat the surface of silica with the different chemicals. Mainly they are different type of the silanes, they are available. And those chemicals, they are known as the coupling agent or the bridging agent or the reinforcing reinforcing agent. So what we do, we take those chemicals, so we take the silanes, we treat the silanes with the silica, and those silanes they actually react with the hydroxyl or silanol group, and when they react with the hydroxyl or silanol group, they make the chemical bonding with the silica, and now the active site would be that silane rather than the presence of the simple hydroxyl or silanol group on the surface. So if we treat it, then after treatment, this silica would be the better filler as compared to carbon black for the reinforcement of the rubbers and reinforcement of the polymers. And the activated silica or the salinized treated silica would give us the better mechanical performance, would give us the better dispersing properties as compared to the normal non-treated silica. And in fact, the carbon black do have some active sites, and those active sites, they are actually the polyaromatic hydrocarbons which are present on the surface of the carbon black. And due to presence of this polyaromatic hydrocarbons on the surface of the silica, surface of the carbon black, it slightly becomes carcinogenic in nature, because the polyaromatic hydrocarbons, they provide or they are the potential carcinogens. So that's why the use of the carbon black should be a bit restricted, and the manufacturing bit should be a bit more controlled, so that we don't have the polyaromatic hydrocarbons as the active sites on the surface, because they are they are not good for the health of the human beings. They are carcinogenic. So we do have a potential carcinogenic or effect from the carbon black. That's why mostly people, they are now moving from the carbon black to the silica, due to the number one is carcinogenic effect. Number two, the performance which we can get from the silica after treatment, that would be much more as compared to the performance that we get from the carbon black. And also nowadays, the oil prices, they are hiking, and the increase in the oil price, carbon black is also becoming a bit more expensive. So silica would be the better option as compared to the carbon black. We did use the different fillers in our. We check the effect of the different fillers on the compound of the different polymers and the elastomers. You can see on your screen there is a graph which is showing the effect of the tear strength with the loading of the silica. As we increase the silica loading from 0 to 6 pHr, you can see there is an increase in the tear strength. So that up to the 5 pHr loading, and afterwards there is a bit decline in the tear strength. So we can see that in the acrylonitrile butadiene rubber, where we have added the chitosan as our bow filler. If we add the silica, we can get the better properties as compared to only the chitosan, which is present at the loading of the 30 pHr. So similarly, the other properties, just like the tensile strength and the elongation at break, that also increases with the increase in the loading of the silica. As we increase the silica loading from the up to 10 pHr, you can see there is an increase in the tensile strength, also in the elongation at break, and that increase shows that the silica can be used with the different other biofillers, just like the chitosan, and it would help us providing the better mechanical performance as compared to the chitosan. Similarly, the effect of the silica can also be seen on the abrasion index. With the increase in loading of the silica, abrasion index of the rubber increases. Here in this case, up to 1 pHr, we get the increase in the loading of the increase in the abrasion resistance of the chitosan filled NBR. But if we further increases the loading of the silica, there is not sufficient change in the abrasion index, and it makes a plateau. So up to 1 pHr, we can say there is a maximum increase in the abrasion index, and onward there is an increase, but that increase is a bit not as much as compared to the up to 1 PHR. So when if we take the examples of the different other compounds, just like the PPRC, EPDM blends, and if we look at the properties, the compounds which are having the fillers, and silica as a filler, that shows you the better modulized. Just like you can see here, the compound having the 10 PHR of the rubber content in the PPRC, which and silica up to 5% loading. So it gives us the better performance as compared to the non-reinforced compound having no loading of the silica. Similarly, with the increase in the rubber content, similar trend we get the modularized increases as we incorporate the silica as the nanofiller in our compound. The impact strength also increases in the similar kind of the blends with the incorporation of the silica as a nanofiller. So there will be the effect of the elastomer as well, because we are adding the EPDM in the PPRC. So with the increase in the EPDM content, there will be increase in the impact strength. But as if we compare these with the other compound which are also having the similar kind of the EPDM loading, so when we add the silica, so the impact strength of our compound that also increases, and which shows that the silica can also help us in getting the better impact strength in the different plastic parts, which can be potentially used for different application for the automotives. Similarly, we also check the effect of the different hybrid loading of the filler. We had that different we had the carbon black, we had the silica, and we had the calcium carbonate. Carbon black and the silica both are the nanofillers. Calcium carbonate, that's not the nanofiller, but it's in the micron side. But mainly to make the compound cost effective, we have to add the calcium carbonate as well. So in this you can see the effect on the modulized as we increase the loading of the filler, the modulized of the compound they increases. There's a lesser change in the moduli as we add the carbon black, and there's a more change in the moduli as we incorporate the calcium carbonate. But the maximum change in the moduli will be get when we incorporate the silica as the nanofiller. So out of all these three filler, if we compare, that silica would give us the better increase in the moduli as compared to the carbon black and the silica and the calcium carbonate. If we compare these three fillers in the automotive application, the silica would be the better option as compared to the carbon black and the calcium carbonate. But still, carbon black and the calcium carbonate, due to this cost effective nature, they are more in use in the Pakistani local automotive manufacturing parts manufacturing industry, because at the moment the surface treated silica that's more expensive as compared to the carbon black and the calcium carbonate. But I think in near future it will be the in the same cost range as the carbon black. So industry would move towards the silica as well. So, and also silica gives us the better mechanical performance as compared to the carbon black. So I'm of the view that in our industry, if we move from carbon black to silica, we can get the better results. But at the same time, carbon black is the still good option due to its cost-effective nature, and calcium carbonate is the very cheap, and it is mainly a cheapener in our compound. So we don't look at the properties when we use the calcium carbonate, but we only look at the price effect which we get by use of the calcium carbonate in our compound. So overall, to conclude all these things, we can say that different fillers which we can use, the calcium carbonate, silica, and the carbon black. The silica and carbon black, they are more better option for the reinforcement, and the calcium carbonate, it is the only cheapener in our industry. We don't have the other options which are just like the CNTs which are available as a nanofiller, but in our industry we are not using those kind of the fillers because they are mostly used in the concept vehicles which are having the different parts loaded with the CNTs and the different other things. So in our industry, I think at the moment silica would give us the better mechanical performance, and definitely the industry has to look at the other options of the cheaper fillers which are available locally, just like talc is also available in Pakistan, kaolin is available in Pakistan, but we need to look at the different surface treatment mechanism which can be used with the talc and the kaolin to make them more better performing as compared to the carbon black and the silica. That's all from my side. If you have any question with that, we can have the question at the end of the session. Thank you very much. Bye.
Thank you very much, Dr. Farhan. It's an interesting presentation focusing on the various fillers, particularly your research on the silica versus carbon black and calcium carbonate. Thank you very much. Guys, if you have any questions, we can discuss those questions or points at the end of the presentation. Please post your points in the question box, please. Okay, let's move to the next presentation, which is on the development of polymer gel electrolytes, shortly called PGEs, for energy harvesting application. This presentation will be given by Dr. Umar Muhammad, an assistant professor at the University of Engineering and Technology, Lahore, Pakistan. So let's welcome Dr. Umar to make a presentation on the topic of the development of PGEs for energy harvesting applications.
Hello everybody, I am Dr. Umar Mahmood, serving as an assistant professor at the Polymer and Process Engineering Department of UET Lahore. My area of research is thin film solar cells. Currently, I am working on the development of polymer gel electrolytes for dye-sensitized solar cell application. This research project is funded by HEC Pakistan under the head of CPEG. It is joint project of UET Lahore and Harbin Institute of Technology, China. My co-PI in this project is Professor Yong, belongs to Harbin Institute of Technology. The outline of my presentation would be introduction, major advantages of DSSC, structure and working mechanism, and lastly, I will briefly explain my research work. Solar radiation, basically the sun is made up of about 80% hydrogen and 20% helium. Its radiant power comes from nuclear fusion process. Each second, more than 400 million tons of matter are converted into energy within the sun core, producing neutrons and solar radiations. As you can see in the figure, the solar spectrum covers the near ultraviolet visible region and infrared spectrum. Specifically, 5% is UV radiation, 43% visible radiation, and 52% infrared radiation. Each of these bands has a different impact on the environment. The amount and intensity of solar radiation that a body receives depends on a variety of factors. These factors include latitude, season, time of day, cloud cover, and altitude. Not all radiations emitted from the sun reaches the Earth's surfaces. Much of it is absorbed, reflected, or scattered in the atmosphere. Potential energy is considered as a potential source of energy. As you know, the world power consumption, which is 13 terawatts currently, is expected to reach about 23 terawatt in 2050. So solar power is the key to a clean energy future. Every day the sun gives off far more energy than we need to power everything on the earth. It is renewable source of energy. Solar cell produce electricity by transforming the continuous flow of energy from the sun to electricity. Also, it is combustion-free process. No harmful emissions are released into the air when electricity is produced by solar panels. As you know, solar cells are devices that use the photovoltaic effect to convert the energy of light directly into the electricity, producing no electric charges that can move freely in the semiconductors. The process was discovered as early as 1839, but the first solar cell was introduced by Bell Executive in 1954. Unlike batteries or fuel cells, solar cells do not utilize chemical reactions or require fuel to produce electric power. And unlike electric generators, they do not have any moving parts. The types of photovoltaic cell, basically solar cells are generally classified into four generations depending on the time and category of materials which are used for their fabrication. The most common solar cells available in the market are the first generation solar cell, which comprises single and multicrystalline silicon. Second generation solar cells were introduced as a response to high material usage and cost of silicon solar cell. To reduce the material usage, the maximum film thickness for this generation was brought down to a few nanometers to tens of micrometers. Meanwhile, many researchers have attempted a light management concept using dye-sensitized solar cell, perovskites, organic solar cell, quantum dot solar cell, and nanostructuring and as well as nanopatterning. Um, Still, the silicon-based solar cells are most demanding in the market of photovoltaic cells due to high efficiency of approximately 15 to 20%. However, their energy-intensive processing, rigidity, reduction in the efficiency at higher temperatures, and requirement of extremely pure silicon are the prominent concerns in silicon solar cells. The presence of these concerns stimulated the researchers to investigate the novel organic materials for photovoltaic applications. Similarly, perovskite solar cell give the highest power conversion efficiency. The most recently recorded power conversion efficiency of perovskite is 23% in the single junction layout. But perovskite solar cells are least stable against humidity and oxygen. And also the complexity in their fabrication process provides significant complications in their commercializations. Similarly, polymer-based solar cells also involve a complex process for their fabrications and are less efficient. However, on the other hand, uh, DSSC are much easier to fabricate and their efficiency has improved from 7% to 14%. So DSSC possess an efficient power output in the entire range of light spectrum, including LED or indoor fluorescent. Even they can work efficiently in the condition of diffuse dim sunlight. whereas silicon-based solar cells are not as efficient and perform rather poorly under these lighting conditions. Uh, it was invented by Michael Gritzel in 1991. At that time, its efficiency was only 7%. So his research was published in Nature. So that was the first paper on DSSC. So what are the major application of DSSC? DSSC found to be very useful, particularly in the applications of wireless sensors networks, sports and medical devices, cameras, security sensors, and wearable electronics. A substantial amount of these smart electronics and wireless sensor networks are included in the Internet of Things environment that promises the vast network of connected devices gathering the big data on which our production, medical, infrastructure, and industries will be examined and optimized. These sensor devices require exceptionally low power input of their application, and it will be a remarkable if they could be driven by low light or indoor power gathering systems. Thus, DSSC can be a potential candidates for IoT's applications. What is the latest trend in the market? Many companies are fabricating DSSC globally due to increase in the market potential that is estimated to grow 12.4% from 2015 to 2022. DSSC were worth 49.6 million USD in 2014, and it is estimated to be capture 130 million USD by 2022. The emergence of DSSC in the photovoltaic market is huge as companies like Dysol has officially started its new manufacturing facilities in Australia on October 2008. Later on, it has announced a partnership with Tata Steel for large-scale manufacturing and development of building integrated photovoltaics. Another companies, if you see 3G cell uh, and G cell, both belong to Israel, are fabricating DSSC modules for wireless electronics. Um, as you can see, uh, DSSC is traditionally fabricated using two sheets of highly conductive and transparent materials. Transparent glass coated with indium tin oxide and fluorine doped tin oxide act as a substrate. However, FTO is preferred because its sheet resistance remains constant upon sintering. Similarly, semiconductor metal oxides are used as a photoanodes of DSSC. Its function is to absorb dye and transform electrons to the external circuit. So titanium oxide is regarded as an excellent semiconductor due to good photocorrosion resistance and substantial electronic properties. The major component of DSSC is the die. That is the third component. Its function is to absorb light and injects electron to the conjunction band of the semiconductor. An efficient photosensitizer must absorb sunlight in the visible region, that is from 400 to 700 nanometer. Similarly, the fourth major component of uh, cell is electrolyte. The function of the electrolyte is to regenerate the dye after it injects electron into the conduction band of semiconductor. However, the long-term stability of DSSC depends on the properties of electrolyte. Similarly, another important component of the DSSC is the catalyst. Its function is to accelerate the reduction reaction at the counter electrode for the regeneration of electrolyte. An optimal counter electrode should possess good catalytic activity and high conductivity. So in this regard, platinum is considered as a best catalyst properties for DSSE application, but it is an expensive noble metal, show poor corrosion resistance against electrolyte. So alternate materials like carbon allotropes and conductive polymers can also be utilized for the applications of DSSE. So what is the working mechanism of DSSE? As you can see in the figure, dye molecules are attached to the metal oxide semiconductor through a covalent bond. The adsorbed dye absorbs solar radiation and electrons in the dye become excited. So electrons tend to move from low energy level to high energy level. The highest occupied molecular orbital is considered as low energy orbital, while the lowest unoccupied molecular orbital is regarded as the high energy orbital. The electrons are then infused into the conduction band of the metal oxide semiconductor. They pass through a mesoporous thin film of semiconductor and finally collect at conductive substrates. So electrons from photoanode then reach at a counter electrode through an external circuit, as you can see in the figure. Meanwhile, electrolytes regenerate the oxidized dye and then diffuse towards the counter electrode. At counter electrode, a reduction reaction takes place and the electrolyte is regenerated here. So in this way, the working cycle of DSSE is completed. So what are the major challenges in the commercialization of DSSE? So there are three major challenges in the commercialization of DSSE. These include stability, replacement of electrolytes with gels or solid state polymers um, can enhance the efficient stability of solar cell. Similarly, the other challenge is efficiency. uh, how to increase the efficiency? Efficiency can be increased by modify the photoanode to enhance the light scattering efficiency and charge collection efficiency. Similarly, cost is the major factor. So replacement of expensive components such as platinum with conductive polymer can reduce the cost of the device. So the primary focus of our research is to enhance the stability of DSSC. As we discussed in some previous slides, the long-term stability of dye-sensitized solar cell depends on the property of electrolyte. Therefore, the electrolyte must have the following characteristics. First one is as a high electrical conductivity and moderate viscosity for faster diffusion of electrons. It should not cause desorption of dye from the semiconductor surface, and also it should not absorb light in the visible region. So electrolytes for DSSE are classified into two types, and the first one is liquid electrolyte and the last one is solid state electrolytes or polymer gel electrolytes. Liquid electrolytes basically consist of redox, couple, organic solvent and additives. However, high evaporation rate and leakage limit the long-term stability of DSSE based on liquid electrolyte. So in order to improve the performance, stability, solid state electrolyte have been developed. Uh, Polymer gel electrolytes contains a polymer, solvents, and salt. Ionic conductivity of polymer electrolytes depend on various factors such as molecular weight of the polymer. Higher the molecular weight, lower will be the conductivity. Similarly, the concentration of polymer. Concentration of polymer inversely affect the conductivity of electrolyte. Similarly, the concentration of salt enhances the conductivity of electrolyte. As a whole, polymer electrolytes can be divided into two categories. The first one is thermoplastic polymer electrolytes. Thermoplastics include polyvinylidene fluoride or PVDF, and thermoset setting polymer electrolytes. These include polyacrylic acids and polyethylene glycol. Currently, the main objective of our research work is to develop polymer gel electrolytes using conductive polymers and fluorinated polymers. In case of conductive polymers, we use polyaniline as a host material, while in case of fluorinated polymers, we are specifically using polyvinylidene fluoride or PVDF. First, I will briefly explain the synthesis of penny multi-wall carbon nanotubes based polymer gel electrolytes and its effect on the stability and the photovoltaic performance of DSSE. So, the first is synthesis of nanocomposites that is based on polyaniline and multi-wall carbon nanotubes. The first step is as ammonium persulfate was dissolved in HCl to get a uniform solution. Secondly, the acidic solution of aniline was prepared by dissolving 5 ml of aniline in HCl. Next, the precise amount of multi-wall carbon nanotube in a 1 molar solution of HCl was dispersed by sonication for 30 to 40 minutes. Then these three solutions were mixed and then stirred for 24 hours at 0 centigrade. Initially, the prepared solution was filtered, washed and dried at 40 centigrades for 24 hours. The samples were prepared in a similar way, just by varying the amount of multi-wall carbon nanotubes. Similarly, the next step is how to synthesize the polymer gel electrolytes based on nanocomposite. The synthesized nanocomposite were used as a base material to prepare polymer electrolyte. In the first step, ethylene carbonate and propylene carbonate were mixed in equal parts at 45 centigrades for 10 minutes with stirring of 300 rpm. Then 0.1 gram of potassium iodide salt was added to the above mixture and stirred at 80 centigrade for 60 to 80 minutes. After that, a fixed amount of nanocomposite was added at 100 centigrade with a constant stirring for 2 hours to achieve a homogeneous solution. Finally, iodine was added to the above solution and the whole mixture was kept at a constant speed for 15 to 20 minutes. The other electrolytes with different salt concentration were prepared in the similar way. Now, how to fabricate the solar cells? The first step is titanium coated glass were heated at 450 centigrades for 30 minutes. Then coated substrates were dipped in a 0.5 millimole dye solution for 24 hours. So after complete sensitization, photoanodes were washed with methanol to remove the free dye. Similarly, you see on the figure, platinum coated substrates were annealed at 450 centigrade for 50 minutes to make the counter electrode. After fabrication of both electrodes, prepared solid state electrolytes or polymer gel electrolytes was deposited on the photoanode. Then it was heated for 50 to 60 minutes at 50 centigrades. And both electrodes were then joined together by super glue or epoxy based adhesive. So this is the fabrication of solar cell. Uh, the morphological specific crystal structure and coordination between the ingredients of composites have been investigated by scanning electron microscopy, X-ray diffraction, and Fourier transform infrared spectroscopy analysis respectively. Whereas the performance of electrolytes were characterized by their ionic conductivity. Similarly, the photovoltaic performance of fabricated cells was evaluated by current voltage characteristics. So the Fourier transform infrared spectroscopy, you see the figure, the spectrum of penny or polyaniline, a peak at higher wave numbers of 385 is accredited to the stretching of the NH group. Similarly, the bands at 2816 are due to the unbalanced CH expansions of the aromatic ring, while peaks at 1565 corresponding to the C double bond stretching. Uh, Thus, the characteristics peaks at 1141 and 8813 are assigned to in-plane and out-plane bending vibration of aromatic CH respectively. Similarly, the OH stretching vibration of the carboxylic group in the multi-wall CNTs shows a peak at 3460. The sp3ch stretching of the benzene ring is represented by broad peaks at 2815, 2879, and 2953. While the band at 1602 and 1375 is assigned to C double bond O stretching vibration and C single bond group. If you see the spectrum of nanocomposites, uh, peaks at 3138 and 3351 are attributed to CH and OH bond respectively. The shifting of peaks position in the spectrum of composites was observed. These shifts in the wave number after mixing of CNTs in penny confirm the conformation of composites between both constituents. Similarly, the SEM analysis, you see the figure A, the flakes of pristine penny polymerized by in situ polymerization are presented in figure A. It can also be seen in figure B that a nanocomposites containing 4 to 8% of multi-wall carbon nanotubes show a good dispersion. The dispersion of multi-wall carbon nanotubes in composite is responsible for the better adhesion as well as continuous morphology of nanocomposites. Similarly, the good contact between constituents of nanocomposite provides an effective path for the electron flow. However, agglomerates of CNTs can be observed at higher CNTs contents at 6%, 8%, and 8 weight%, as you can see in the figure C and D. The agglomerates formations degrades the continuous morphology as well as the adhesion between the components of nanocomposites. The low adhesion and disjointed path resist the flow of electron and thus poor conductivity of the composites. So X-ray diffractions, and as you can see, figure demonstrates the XRD patterns of pristine penny and nanocomposites having 2 weight%, 4 weight%, 6 weight%, and 7 weight% of CNTs. Uh, Pristine penny shows a sharp peak at you see 2 theta is equal to 25 degree and 3 minor peaks at 20.62 and 14 and 8.9 degree. These characteristics peaks are attributed to the periodicity parallel and perpendicular to the chains of the polymer. The intensity of these peaks is comparatively high compared to pristine penny, owing to structural ordering of the penny on multi-wall carbon nanotube surfaces. So it also confirms the adhesion between penny and multi-wall carbon nanotubes as confirmed by SEM images. Similarly, sharp peaks at 25 degree and 26 degree have also been observed for 4%, 6%, and 7 weight% multi-wall carbon nanotube composites. The minor broadening peaks of composites could be attributed to the formation of nanocomposites. So the polymer gel electrolytes can be characterized by their ionic conductivity. So the figure shows that the ionic conductivity increases with CNT contents in the composites. So the nanocomposites show higher conductivity compared to pristine penny. So it is because penny possess an interstitial structure and electrons may lose their energy in gaps. So in order to improve the morphology or structure, aniline is in situ polymerized with multi-wall carbon nanotubes. The one-dimensional structure of multi-wall carbon nanotubes may fill the empty spaces and provide an effective path for the movement of electrons. Thus, 4-weight% composite-based electrolytes show higher conductivity value compared to other electrolytes. But conductivity falls to low value with the further increase of CNT contents in the composites. It may be due to agglomerates formation at higher CNT contents. Similarly, it shows that salt concentration also affect the conductivity of electrolytes. It increases with increasing salt contents and then decreases with further increase of concentration of salt. The high conductivity value you see on the figure, that is 197 microsiemen per centimeter for composites containing 4-weight% CNT at zero point 0.5 gram of salt concentration. So thus the combined effect of CNT and salt increases the overall conductivity of the electrolyte system. The current voltage setup was used to investigate the photovoltaic performance of solid state DSSC under the light intensity of 100 milliwatt per centimeter square. So maximum current density, short circuit current density, maximum voltage and open circuit voltage were calculated from JV curves, while the fill factor and efficiencies were computed using the following relations. That is, fill factor is equal to Vmax into Jmax divided by VOC into JSC. So efficiency is equal to VOC multiplied by JSC divided by power input into fill factor. So the as you can see in the table, the calculated photovoltaic parameters of solar cells. So these results demonstrate that efficiency and fill factor both depend on the current and voltage values of the fabricated cell. However, the tabulated results show that VOC or open circuit voltage approximately remains constant for each cell. It is evident from the results that the conductivity pattern directly matches with the current density of DSSC. As discussed in the conductivity section, the synergistic effect of CNTs and salt increases the conductivity of the electrolyte system. Thus, the current density increases with CNTs and salt concentration. The solar cells fabricated with optimized quasi-solid state electrolyte or polymer gel electrolyte revealed superior performance, as you can see in the table. However, it also shows that the performance of the cells goes down at higher CNT and salt concentration. So what could be the reason? At higher CNT contents, agglomerates form, act as a trapping sites and provide a hindrance to the flow of electrons. Similarly, salt remains undissolved at a higher concentration, providing resistance in the flow of electron. Thus, the efficiency or performance of cell drops at higher concentration. If you see the table, that fill factor increases with CNT contents. Higher the fill factor, more will be the forward flow of electrons and vice versa. So low fill factor stimulates the breakdown recombination reaction within the cell. So efficiency of the cell becomes low at higher CNT contents or at higher salt contents. Uh, this table shows that the liquid electrolyte based DSSE shows higher efficiency of 4.95% at the start, which is superior to the device fabricated with polymer gel electrolytes. However, after a week, the efficiency of polymer gel electrolytes based DSSE remains stable, while the efficiency of conventional DSSE approaches to zero. The stability of DSSE is an important aspect of their commercialization. Thus, the fabrication of DSSE using polymer gel electrolyte is an easy way to enhance the stability of DSSE. Uh, this research work has been published in the International Journal of Energy Research, having impact factor 5.167. So this is the outcome of our latest research. Similarly, there's a case study too. We also developed polymer gel electrolytes using fluorinated polymers. These polymers have advantages over other polymers as they show strong degradation resistance against ultraviolet light. So the most commonly used fluorinated polymer is PVDF or polyvinylidene fluoride. The other materials used in this research were potassium iodide, which act as a salt and increases the conductivity of the system. Uh, Similarly, ethylene carbonate is used as a solvent. Propylene carbonate is used as a plasticizer and keeps the viscosity of the system moderate. Uh, while the iodine is used as a reducing agent in this research. So similarly, the synthesis of gel electrolyte that is very simple. The ethylene carbonate and propylene carbonate were stirred together for 30 minutes. The precise amount of potassium iodide was added into the EC and PC solution. The whole mixture was stirred at 80 centigrade for 60 minutes. Subsequently, PVDF was added into the above salt solution and the mixture was again stirred at 180 centigrade until the gelation occurred within 15 minutes. Finally, iodine was added with continuous stirring at a temperature of 120 centigrade. The same methodology was used to prepare the other electrolyte samples, with the only difference being the amount of the salt used. Similarly, this is the conductivity curve. As you can see in the figure, the conductivity of polymer gel electrolytes increases with increasing the salt concentration. It shows the highest conductivity value of 300 microsiemens per centimeter at 0.09 gram of salt. However, it can also be observed that the conductivity decreases at higher salt concentration due to ion cluster formation. Saturated solution shows maximum conductivity as the concentration of salt further increases from the saturation limit. It will not dissolve and remain as a cluster, which reduces the ionic conductivity of the solution. Similarly, the photovoltaic performance and stability of DSSE. If you see the table, this table shows that the conventional DSSE or liquid electrolyte based DSSE possess higher efficiency as compared to polymer gel electrolyte based DSSE. But it can also be seen in the figure B that the efficiency of the conventional DSSE decreases with the passage of time. However, the performance of polymer gel electrolyte based DSSE remains stable after 40 days. So this is the major advantage of polymer based electrolytes. So this over research has been published in IEEE Journal of Photovoltaics. Its impact factor is 3.789. So this is the second outcome of our research works. Thank you so much for listening this presentation. So
Oh, it's a very interesting presentation on the PGEs. And actually, the Homer explained nicely about all the issues about solar energy and how to harvest the energy from the solar. Very nice presentation, Dr. Homer. Thank you very much. And
thank you, Fred. Thank you so much.
if you guys have any questions on this topic, please post the questions in the question box. We will address them at the end of the the presentations. Okay, let's move to the next presentation. This is about the effective polymer processing techniques for plastics part production using nano fillers. This person will be Engineer Mudassar Khurshid. He is a researcher at the University of Energy and Technology, Lahore, based in Pakistan. So let's invite Mr. Mudassar to give a presentation on the effective polymer processing techniques for plastic parts production using nanofillers.
Hello everyone, my name is Mudassar Khurshid and I'm doing MSc in Polymer Process Engineering from UT Lahore under the supervision of Dr. Yasser Qiyum Gill. Today I will be presenting the effective polymer processing techniques for plastic part production using nanofiller. So let's start. Plastic waste is a representative of a waste product that originates from industrial development and its discharge to environment causes severe environmental problem. Currently, plastic products are an essential part of people's daily life and are applied in various industries such as construction, healthcare, electronics component, agriculture, and automotive. The demand for plastic continues to increase due to excellent advantages of plastic such as convenience, durability, resistant to erosion, ease of processing, and low cost. Global plastic production has grown at a compound annual growth rate of 8.4%. The annual plastic production was 360 million ton in 2008 and plastic production is estimated to reach 50 million ton in 2025. Only 9% of plastic are produced have been recycled. The other fractions of plastic waste are either incinerated or landfill or lost to the environment. According to an estimate, 12% waste is incinerated and 79 is ends up in landfill. The demand of plastic mainly comprises polyethylene, polypropylene, polyvinyl chloride, polyethylene terephthalate, polyurethane, and polystyrene. Polyolefins such as polyethylene and polypropylene are the most demanding plastic throughout the world. Packaging industry consumes the highest portion of plastic products and it is major plastic waste source because of the well-known application of disposable products. Plastic waste undergoes slow degradation and can remain in environment for at least decades or even hundreds of years and cause serious environmental issues. These practices of landfilling and incineration is huge loss in terms of valuable material and energy used to make plastic products. It is necessary to decrease the environmental impact of plastic waste and to adopt the circular economy to replace the current linear economy. In a circular economy, products and materials are being reused, refurbished, or recycled according to the waste ladder, instead of being incinerated or disposed. Plastic waste can be divided into four classes: primary recycling, secondary recycling, tertiary recycling, and quaternary recycling. Primary recycling, also known as closed loop recycling, is a process of taking uncontaminated discarded plastic and turning directly in that material into the same new product, ideally without loss of properties. A familiar example of this would be to use a clean aluminum pipe and use the metal to make a new aluminum pipe. Secondary recycling refers to the mechanical recycling, where the chemical identity of the polymer is unchanged, but the polymer is in some way physically reprocessed and generally used for different purpose than its original use. An example of this is taking the waste tire and using the rubber crumb as addition in rubber flooring or park benches. In tertiary recycling, waste plastic is used as a feedstock in process that generate chemicals and fuel. An example of tertiary recycling is the glycolysis of polyethylene terephthalate into diols and dimethyl terephthalate that can be used to make virgin PET. In quaternary recycling, energy is recovered from waste plastic by incineration. Dried fuel is an example of quaternary recycling. In the context of polymer, the most prevalent problem with primary and secondary recycling are related to the stability. As the polymer are continuously reprocessed, the polymer may degrade to different extent, which will have drastic effect on the mechanical properties of the post recycled product. Additionally, the need for pure clean plastic waste is a significant barrier when post consumer mixed source plastic is targeted for recycling. From environmental point of view, mechanical recycling of waste plastic is considered the preferred option. Despite odorous emission released during the meltdown of waste plastic and soil contamination which affect environment and human health, mechanical recycling is generally environmentally friendly approach for waste plastic disposal. Persistent organic pollutants can be released from energy recovery, which would damage the environmental performances of these processes. Besides, there is a lack of commercially successful energy recovery of operations due to technological limitation, operating cost, and variable quality of feeds. Moreover, no energy recovery method offer a net positive energy balance. Generally, recycled plastic can be regarded as renewable source of material, and utilizing them in manufacturing could greatly reduce greenhouse emission and carbon footprint. Aside from environmental benefit, mechanical plastic cycling is an economical viable practice, as recycled plastic represent a save of 20 to 50% in terms of market price when compared to virgin counterparts. For promoting the mechanical recycling, various methods have been proposed to promote the quality of recycled plastic, including filler addition, compatibilization, process optimization, and formula design. Most commonly employed preparation method is the melt process due to its advantages such as high efficiency, easy operation, continuity, and industrialization. However, simple blending of inorganic particle with the polymer material, which is practical from the point of view of direct manufacturing of composite particle, is not able to provide the desired homogeneous particle distribution. Clustering consists of highly aggregated particles was generally observed due to high surface energy of the particle and the incompatibility of the chemistry of the surface of nanoparticle with many matrix and polymers. That's why it is necessary to develop the method for effective dispersion of nanofiller in polymer. The following session will represents the studies which have been performed to improve the dispersion and distribution of the nanofiller. The first study is the preparation of carbon black and polypropylene nylon composite with the low percolation threshold using mild blending method. In this study, a new approach, mild blending method, was reported to prepare carbon black filled polypropylene nanocomposite. Carbon black suspension was prepared by dispersing the carbon black powder into deionized water using ultrasonic irradiation for 10 minutes. The intermeshing co-rotating tin screw was used to prepare the nanocomposite. Polypropylene was put into the extruder and melted at 170 degree in the knitting block at the end of feeding section. After that, carbon black suspension was pumped into the second inlet of the extruder and compounded with melting polypropylene in compounding zone. The water content of carbon black suspension was removed from the vent by vacuum to obtain the nanocomposite. Finally, extruder was thermally compressed to prepare sample for complete characterization of nanocomposite. In order to observe the impact of mild blending method on dispersion of filler, carbon black and polypropylene nanocomposite and simple composite of carbon black and polypropylene were analyzed using the SEM analysis. SEM micrograph of the common carbon black and polypropylene composite as shown in figure A showed that most particles were aggregated together and aggregation detached from each other. At higher carbon black content, the scale of aggregation increased, which was caused by the connection of carbon black aggregation. The morphological feature of the carbon black and PP nanocomposite during using melt blending method as shown in figure B displayed a different structure from conventional carbon black and PP composite. It was observed that carbon black particle were detached from each other at nanometer level with the homogeneous distribution in polymer matrix. Correlation between volume resistivity and carbon black loading for the carbon black and PP nanocomposite and common carbon black and PP is shown in figure C. The carbon black and PP nanocomposite prepared using mild blending method was found to percolate at a threshold of about 2.49 volume percentage of carbon black, whereas common carbon black and polypropylene composite had a percolation threshold of about 7.66 volume percentage. This change in percolation threshold between the two carbon black and PP composite could be explained in light of the dispersion and distribution of carbon black particles. Conductive network formed in common composite at high loading of carbon black due to the close contact of aggregate. The percolation threshold at lower loading of the carbon black in nanocomposite prepared by the melt blending method could be explained by the tunneling conductivity mechanism. In carbon black and PP nanocomposite, the carbon particle were dispersed as a primary particle state. Located apart from each other and enclosed by the PP, which is an excellent insulator. This arrangement satisfies the requirement of tunneling conduction. When PP contact when carbon black content reached the percolation threshold, the effective tunneling zone of the nearest neighboring particle overlapped and tunneling conduction occurred. Overall, these research show that nanocomposite can be fabricated successfully by compounding polypropylene with the nano carbon black aqueous suspension using mild blending method. In another research, a novel approach of preparing polymer and nano calcium carbonate composite was presented. A certain amount of nano calcium carbonate particles and ethanol were introduced into the dispersion vessel and particles were wetted sufficiently by mixing for 10 minutes. Deionized water was added in the vessel and ultrasonic sonic transmitter was used to break apart the aggregate structure of nano calcium carbonate and uniformly disperse the nanoparticle into the suspension. Then the resulting nano calcium carbonate suspension was injected into the polymer melt in a co-rotating twin screw extruder under pressure through feed tube and a second inlet drilled on the barrel of extruder. The nanoparticles were mixed with the molten polymer and transported ahead. Then the moisture was volatile from the escape hole and nanoparticles were held in the matrix at the primary diameter as in the suspension. The extrudate was then pelletized. After drying to remove the attached moisture during the extrusion and pelletizing, the pellet were injected into both dumbbell tensile sample and impact sample. Transmission electron micrograph of the nano calcium carbonate suspension is shown in figure A. Transmission electron microscopy analysis of nano calcium carbonate suspension confirmed the presence of primary size dispersion of nanoparticle in aqueous medium. The clear border of primary particle indicated that particles were cubic and diameter varied from 30 nanometer to 80 nanometer. The dispersion of nano calcium carbonate particle in the matrix were assessed by SEM as shown in figure B, C, D and E. Figure B and D show the SM photograph of nano composite of LLDP and nano calcium carbonate and PP and nano calcium carbonate formed with the normal melt mixing method. The particle aggregation in this material range in length about 0.5 micrometer, because the shearing factor was not enough to break the nanoparticle aggregation in the melt. The same micrograph of nano composite of LLDP and polypropylene with the nano calcium carbonate formed with the malt mixing method are shown in figure C and E. The nanoscale nano composite the nanoscale nano calcium carbonate particle and their perfect alignment with the matrix were observed with the composite formed with the mild mixing method. The mechanical properties of nano composite are listed in table. The tensile and flexural properties of four composite are increased with the addition of nano calcium carbonate. However, the impact strength of polycarbonate and polyethylene terephthalate composite showed a slight drop with the addition of nano calcium carbonate. It can be concluded that mild blending method is feasible for preparing both non-polar polymer and inorganic particle, or polar polymer and inorganic particle in nanocomposite. Thermal degradation didn't occur even if water was introduced into the melt, especially compared to neat PP. Iso impact strength and the tensile strength for PP and nano calcium carbonate composite showed a substantial increase with the addition of only 1.5 weight percentage of nano calcium carbonate particles. It suggested that organic nanoparticle with good dispersion state obtained by mild mixing method can play an important role in improving the strength and toughness of PP. The result demonstrated that nanoparticle in all four kind of matrix are in form of primary particle, and this novel technology called the mild mixing method is appropriate for not only non-polar polymer but also polar polymers. Next is dynamic injection molding. In this research, carbon black was premixed with polypropylene pellet in mixer for 10 minutes in various ratios, and that fed into the tri-screw extruder operating at a screw speed of 90 rpm. The resulting extrudate was cooled in water and cut into pellet using pelletizer. The extruded pellets were grinded again in a vacuum oven. Standard samples were molded via custom-made electromagnetic dynamic injection molding machine as shown in figure. Electromagnetic applied vibration with different frequency to study the effect of electromagnetic vibration forces. Morphological analysis was performed to study the effect of electromagnetic forces on the dispersion and distribution of carbon black nanofiller. Micrograph of SEM analysis shown in figure A and B. Figure A shows that micrograph of carbon black and polypropylene nanocomposite without any application of vibration force. It can be seen that distance between carbon black and nanoparticle is large with no vibration, and carbon black particle have no obvious agglomeration phenomena in the matrix. The density of particle distribution is not big enough to the formation of conductive network, because particle can aggregate easily in the molding processing. Figure B shows a micrograph of the carbon black and polypropylene nanocomposite with the application of vibration force. It can be seen that dispersion of carbon black particle in matrix has improved significantly. The average particle size of carbon black particle decreased greatly because of the blending of the melt enhanced. The vibration force has direct influence on the internal structure and the microstructure of the products. Polymer is compressed and released periodically with different vibration amplitudes and frequency under the effect of vibration force. It is beneficial to dispersion of particle and the formation of conducting network structure. Figure show the electrical conductivity and shielding effectiveness of composite with different loading of carbon black. The electrical conductivity of Electrical conductivity and shielding effectiveness of carbon black and PP composite increase with the loading of carbon black changing from 10 weight percentage to 30 weight percentage. The electrical conductivity of composites show a dramatic increase of 10 order of magnitude as the loading increase from 15 weight percentage to 20 weight percentage, indicating a percolating phenomena. Carbon black have been condensed to a special chain structure and produce a large number of conductive chains and branches. After applying vibration fees fall to the injection molding process, the rising trend of electrical conductivity is similar with the result of no vibration. Compared with the no vibration, the electrical conductivity has great increase when the content of carbon black is more than 50 weight percent because of introduction of vibration force field. Overall research on the properties of PP and composite products by dynamic injection molding showed that the introduction of vibration force field could effectively improve the dispersion of filler and differences of electrical conductive distribution in different parts of the composites. Next is solid state drying of post consumer isotactic polypropylene. In this search, the 1.5 percentage of carbon black and isotactic polypropylene pellets were premixed before the polymer processing step. All isotactic polypropylene grades were processed by using a single screw extruder attached to a melt pump and a tape die of 15 millimeter width and 1 mm height. Melt filtration was achieved with a filter of different mesh sizes ranging from 80 micrometer to 250 micrometer. The tape were quenched with the chilled rolls and a drying line with 4 controllable induction heated roller sets and 2 induction heated oven were used. The oriented tape were wounded onto a bobbin and used for further characterization. The fact of mesh size and carbon black is presented in the table. It can be observed that for Vision PP, the addition of carbon black result in reduced draw ratio. By the addition of carbon black, the maximum attainable draw ratio is lower since this acts as a contaminant. The addition of carbon black to recycled isotactic polypropylene show the opposite effect. In polyethylene and isotactic polypropylene blend, the carbon reside in the polyethylene phase without significantly affecting the viscoelastic or thermal properties of blend. In the solid state drying process, this result in a better process stability by improved stress transfer between the isotactic polypropylene matrix and the PP contaminants. The addition of carbon black to recycled PP resulted in higher attainable maximum draw ratio for recycled isotactic polypropylene. Looking at the material without carbon black in table, it can be observed that maximum attainable draw ratio decrease with decreasing mesh size for recycled isotactic polypropylene. It is clear that presence of solid particle which act as stress concentrator is the limiting factor in this experiment. A fine mesh contribute to more stable process operation and high draw ratio. The effect of melt filter mesh size on the mechanical properties shown in figure A, B, C and D. For both unfilled and carbon black filled material, the elastic modulus and tensile strength are not directly affected by the size of the mesh, but they can be drawn further, yielding drawn tapes with enhanced properties. The maximum tensile strength of 385 megapixel was obtained for post-consumer filled polypropylene with 80 mesh filter at 18 draw ratio, which is an improvement of 15 times compared to the isotropic tensile strength of 20 megapascal. Figure A and B shows the evaluation of crystallinity for unfilled material and carbon black filled material, both as a function of draw ratio. The crystallinity increases with the increasing draw ratio, and the crystallinity of recycled material is lower than the virgin isotactic polypropylene. Focusing on the differences between recycled material, it is seen that melt filtration size doesn't affect the crystallinity. Filter separate solid particles such as PET of size much greater than the laminar thickness. Therefore, the crystal formation is not hindered. Overall, this study presented the potential of solid-state drying process, which significantly enhances the process of recycled isostatic polypropylene. It can be concluded that mild blending method, injection molding, dynamic injection molding, and solid state drying method improve the properties of nanofiller reinforced polymers. Mild blending method improves the properties of polymer which are not affected by the water but can cause to degrade the hygroscopic polymers. Solid state drying method enhances the properties of filled polymer by improving the crystallinity and chain orientation of polymer matrix, but the utilization of drying line make it complex and expensive operation. Now I will present the novel method of preparing the polypropylene and carbon black nanocomposite with the aid of ultrasonication and application of high temperature mixing. This research is being done at the Department of Polymer and Process Engineering, UT Lahore, under the supervision of Dr. Yasir Kumgil. In the first step, waste non-woven polypropylene will be compacted in a vertical compression molding to make thick sheet, because soft fabric cannot be shredded using a small industrial shredder. This hard and thick sheet will be taken to a small scale industrial shredder with high speed sharp rotating blade to reduce the size of the sheet for the next step. In the next step, the coarser particle obtained will be grounded in a small high speed rotating blade grinder to further reduce their sizes. The powdered polypropylene will be combined with the carbon black nanofiller with the help of sonication in a sealed container at high temperature and pressure to enhance the mixing. After complete drying, the mixture of carbon black and PP powder will be blended into a scale lab small scale uh, 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 small scale single screw extruder. The resulting extruder will be size reduced using a shredder and milling machine. The resulting powder will be molded using a lab scale vertical compression molding machine into a square sheet, which will be cut into the specimen for testing purposes. The sample will be characterized using FTIR, DSC, TGA, flammability testing, UV degradation studies, HDT, MFI, optical microscopy, ISERT impact testing, uh, 3-point bending testing, and SAM analysis. The carbon black nanofiller is expected to improve the chemical, mechanical, rheological, and thermal characteristics of reclaimed non-woven PP industrial fabrics. It is expected that properties of resulting polypropylene will be comparable to commercial available grade of polypropylene being used in automobile industries. In addition to the automobile component, the modified polypropylene waste could be utilized in a variety of applications, including electronic devices, casing, hardware accessories, non-food grade container, and so on. This will not only save the environment but also provide a cost-effective solution to the plastic raw materials. Uh, Here are references for the study presented, and
Okay, that's an interesting presentation by Mr. Mudassar.
Thank you, sir.
Nice presentation. You have done a lot of good work, man. Yeah, good work.
Thank you.
Something.
Thank you.
Okay, guys, if you have any questions on this presentation, you can post in the question box, and we discuss now. Yeah. May invite all the panelists, all the speakers to come forward. We will have a short discussion. Please open all your webcams. Okay. the speakers, Dr. Asif, Hamid, please come forward. Good. Oh, it's a lot of informative presentations. I really, put my ears to all the presentations. It's nice, all of you. Thank you very much for being part of this, the Polymer Research Forum. Amit, I'll let you start discussion. I think we have a lot of topics are focused on the fillers, actually. Yeah. So you have plenty of experience. Let's start with you. If there are any questions from the audience, I will kind of include in as part of the discussion. Yeah, Amit, please. Mute your, yeah.
Apparently, just like the last time, have you got any online question from the other attendees? Like they type and send you the question, and then you post it over here, and then the speaker respond to that.
Yeah, if there are questions, I will address it. Okay, let's get started with yours. Yeah.
Okay, I would like to ask one question from Hassan. Like you presented a very good topic regarding XMBR and the impact of various pillars on it. So, does this application has anything to do with textiles? I mean, is it applicable for textiles in one way or another?
Thank you, Hamid. So there's a lot of research going on applying the rubber to the fabric as energy absorption. Because rubber is used for has a very good high dissipation characteristics. So the rubber can be used as a dissipation medium, as an energy absorption medium in high performance fabrics. And so there's a lot of research going on producing more and more lightweight ballistic panels and cost-effective solutions. There's one worry which is expected in rubber. The rubber has a very high trauma, high penetration because of the very elastic behavior. And so it can be mixed with the epoxy to minimize the trauma effect. And so this is what I can say about the application. So there's one more research which is like applying rubber in the 3D what we call weave, 3D woven fabrics. So this is one of the challenging areas to apply the 3D woven fabrics to apply rubber in the 3D woven fabrics. So this is one of the challenging areas.
Okay, interesting. Hassan, so National Textile University has a special focus on the rubber in the rubber application. That's a very nice thing. Yeah. And yeah.
Yes, I have a question from the Hassan. It was a very good presentation, Hassan. Nice work. And I saw in your presentation that you were using the zinc oxide as an activator with the carboxylate nitride butadiene rubber. I also worked slightly type of the rubbers. I found that when we use the very high loading of the zinc oxide, it makes the XNBR scorchy in nature. So it's very difficult to process. So with the 5 PHR, I don't know what was your take on it, but I think 5 PHR is very high loading for XNBR because it acts as a curing agent as well for the XNBR.
So I did not face any difficulty in processing. The objective was to improve the mechanical properties of the rubber. So the processing was very good. So I did not face any difficulty in the processing of the carboxylated nitrile butadiene rubber.
Okay.
It also acts as a.
Can you let me know about the impact test which you performed on the XNBR There was very nice presentation and of the graph where you had the initially high impact strength, and then it was declining. Then I think did you perform it at the room temperature or at the low glass sunshine temperature of the XNPR?
Actually, the Charpy test was performed at room temperature. So as the hardness of the rubber increases, the Charpy impacts show high energy absorption peak, as the sample with the high hardness shows high absorption as compared to the low hardness rubber. So there was 2 peaks observed. The reason for 2 peaks is that the pendulum loses contact with the rubber after the first peak, and then there is a second peak observed. Yes.
There will be no failure, I think. I hope so.
There is no failure. There is no failure.
Because it's above room temperature. Thank
Yes,
you.
yes.
Thank you.
Also perform, Hassan, did you also perform some compression testing during your experimentation?
Can you repeat those steps?
I asked, did you also perform some compression set testing during your experimentation?
No, I did not perform any compression test. Molding was done for preparing the samples. The samples were placed in a compression molding machine. So I did not perform any compression test.
So any point from someone else?
Hassan, would you like to share more info on your institute and what kind of capabilities you have on the rubber industry side? Can you elaborate more? Yeah.
Actually, we are collaborating with the Comcast University and the industry like service industry, which prepare tires and shoes. So we are collaborating with them, and this was my PhD study. So the research we are doing is in preparing the ballistic panels for high impact performance, and so this kind of research we are doing. And the adhesion of the rubber with the fabric. So we are applying PU adhesive and different adhesives to improve the delamination issues faced during the preparation of the composites.
Nice. And are you doing anything work with the technical textiles with reference to tires?
Sorry?
The technical textiles with reference to the tires or belts or anything, conveyor belts?
No, I have not much experience on the conveyor belts, but we have the industry like service industry, which is it is closely working on these areas.
Okay, yeah, super. Thanks, Hassan. Thanks. Anybody else would like to address any issues with Hassan? Amit, are you good?
Hassan, did you just say that service industry is working on some conveyor belts experimentation or research?
They're not working on conveyor belts, but they are working on like specialized areas like tank pads and different areas of defense nature. So they are working on these areas.
Okay.
Okay, thanks, Hassan. Please stay on. We will be touching the rubber issues again. Okay. Let's discuss with Dr. Farhan. He's also in the, I think his presentation focused on the rubber compounds. Particularly, he hinted about silica is the better, much better than the carbon black and other fillers. May I know, are there any silica manufacturers in Pakistan now? Who is offering?
Really, there is no real manufacturer in Pakistan, silica manufacture. Mostly we are getting the silica from the other countries. Yes, we do have the lot of silicate resources available in Pakistan, but there are one or two industries who are converting the silica into the fumed silica, but not really precipitated silica. So only I think one or two industry they are making the silica, but that silica can be used for different other purposes, not for the uh, elastomers where you need the high performance. Because you cannot we in Pakistan we are not having the facility where we can convert the silica into the nanometer sizes. So that's the issue with the silica. If we the silica in the nanometer sizes, then we can't get the better properties in rubbers. Secondly, in Pakistan, there is no surface treatment process available for the silica. I do treat it by myself at the laboratory scale, but on industrial level, there's no surface treatment.
Amit, you must be using utilizing the hand, silica and other fillers. So
Yeah, we are using silica for some of our applications in the industry. But just like Mr. Farhan said, there not only in Pakistan, I mean Pakistan does not produce silica, but even the countries where the silica is being produced, there is I don't think there is pre-salinized silica available from anywhere in the world. We either we use it in the laboratory or we use it in the industrial level in bulk quantity. We have to salinize it to get the optimum coherence with the organic component. Otherwise, it does not impart the characteristics, whatever Mr. Farhan has described in his presentation, whatever we read in the books. Unless it is properly salinized, it will not give you the desired properties.
I think Hamid, there is one company, Evonik, they are producing the salinized silica, which is pre-salinized. They have a few grades. That's a VM3 type, but that's much expensive if we compare it with the carbon black and the simple silica.
Yeah, those must be for some specialized applications, not for the general purpose applications.
Cost more than $4 per kg, and
yeah.
we can't afford it.
Yeah, that must be for some specialized.
Yes. A few industry in abroad, they are using the salinized silica from the Evonik. Then is using tires, tires which they are producing for the Formula 1 and the different other racing tires. But in Pakistan, very much expensive for our industry.
But the silane coupling agents, if you remember, we discussed a few months ago, the silane coupling agents, those are available in different physical forms. And all the variations in the physical forms are intended for the ease of handling and ease of usage and for enhancing the shelf life of the material. Like traditionally, it used to be available in liquid form. And the shelf life of the liquid form of the silane coupling agent is very low. I mean, maybe 4 or 5 months, and that too in very controlled and optimum conditions. And in Pakistan, whether it is industry or it is a university at laboratory scale, we do not have much controlled conditions for the storage of material. So the other forms of the silane coupling agents, like the pre-dispersed with EPDM, or which I am using, which I chose around 2 or 3 years ago when we first started using silane coupling agent. I preferred using it in a pre-mixed blend with EPDM, but that unfortunately was not readily available. So I opted for a pre-mixed blend, 1:1 blend with carbon black. Like if you want to use 2 PHR of silane coupling agent, you have to physically add 4 PHR of that material because the active content is 50%. But as far as the ease of handling, as far as the storage is concerned, that is much more beneficial as compared to using the traditional liquid form of the silane coupling.
Secondly, Hamid, what I observed with the silica that if we don't properly pre-salinize it at a certain temperature, because I observed that if we salinize it at the 120 degree centigrade temperature, we get the better properties as compared to we treat it at the room temperature for pre-salinization.
No,
So
we do
I
not. In Panther times, we do not perform the salinization at room temperature. We basically do it in an internal mixer, and you know, in internal mixer, the temperature, even if it does not reach 120 during salinization, at least it crosses 100 and 105 degrees Celsius. At room temperature, you cannot achieve the salinization, and definitely cannot achieve the desired property.
Yeah, exactly.
Thank you, Dr. Farhan. Actually, I like your presentation. You gave a lot of, critical explanation also about sizes and the surface areas and all the information. Very useful. It was a nice presentation on that.
Thank you. Thank you, Payam.
Param, let me tell you, Dr. Farhan is one of the most experienced and I must say the well-versed person in Pakistan as far as the rubber compounding is concerned.
Super, super. We should talk more afterwards, and we do something together. Yeah.
I have a question from Dr. Farhan.
Yeah.
So, what is the cost difference between the silica and the carbon black? And can you comment on that?
If we just compare the normal silica and carbon black, there's not much difference because in Pakistan the carbon black is somewhere around nowadays prices are hiking, but the carbon black cost is somewhere around 400 or by kg or so. But market is fluctuating day by day, and silica is somewhere around 380 to 400 as well. But there are some grades of silica which are available, which are very cheap. We can get it in 200, somewhere around 200 rupees per kg and so on. But the thing is, if the simple silica cannot provide us the better properties, when we salinize it, we use the silane. The silane increases the cost of the silica. That a good silane somewhere costs us approximately 2,000 rupees per kg or so. So that's a huge cost. If we salinize it with that 12% by loading, so you can say that we can increase the cost. If the cost of silica is 400, we salinize it with the 12% loading of the silane, and the cost will increase up to the 500, 550 rupees per kg. So it would not be cost effective for the industry at the moment.
Another question: what is the environmental effect of the silica and as compared to the carbon black? And
from the environmental point of view, silica is very good because there are issues with the carbon black, as I mentioned in my presentation as well, that there are some polyaromatic hydrocarbons functionalities present on the surface of the carbon black, which makes it carcinogenic in nature. Not all the carbon black, but if you have some uncontrolled manufacturing, then there are the possibility that we can get the carcinogenic functionality of the carbon black. But silica is more environmental friendly as compared to carbon black in the sense that we don't have any health issues related to the silica. But the problem with the silica, it blows away because the particle size is very fine, and when we use it, it spreads a lot during the compounding process as compared to the normal carbon black. So a bit difficult to compound as well.
Okay, that's good. That's good. Let's, where is Dr. Asir? Okay, he's here. Dr. Asir.
Yes, Peter, I'm available.
Okay, hi there. Your camera is not working, man. Can you check it out?
Yeah, there is some internet connection to it.
Okay, fine. Just want to touch, you really had hit the point on the plastic waste, and even I think your research team as well, the Mudas are also in the beginning even talked about the plastic waste issues. The word called circular economy, yeah, right. Is it
Yes.
prevalent in Pakistan, particularly from the material supplier side?
No, at the moment, even the multinational companies are not working on a circular economy of plastic. But they are facing pressures from UN and from other treaties who are basically making these agreements based upon which they have to mend their ways in Pakistan. At the moment, it's just use and throw away, use and from both sides. The manufacturer point of view is will manufacture it and will throw it away into the market. Then it's not our concern. From the user point of view, they are going to use it and then they are going to throw it away, and they say it's not our concern. All the burden then lies on governments. Governments have now looked at UN. United Nations have now gathered 178 nations, and they are going to unify this overall treaty. They're going to sign a uniform treaty, and then based upon that, strategies are going to be developed that are going to be very stringent. They are asking the manufacturers even that they have to reduce in the next 15 years 30 to 40% of virgin polymer production. Because if they are going to reduce the virgin polymer production, then they believe that the utilization will go down. And alternate are going to come from the recycled plastic. They are saying that until and unless all the energy has been extracted from plastic after using it 3 to 4 times in various applications, then making sure it goes through pyrolysis, we recover the chemicals. From those chemicals, you can manufacture various raw material for plastics, or you can polymerize them to produce various polymers. So in this way, a whole circular economy concept is being developed at a global level. As a result of which companies will not have any option. In the future, companies are now being targeted not only based upon their product portfolio, but also on their carbon footprint, also on their plastic utilization. And for a company, if a country doesn't abide by their rules or the regulations which have been set by UN, it would be better for them to ban plastic for that country. On the other hand, just keep on supplying them with unlimited supply of plastic throughout the year. So companies will not have any option that they need to adopt the circular economy, need to look at the life cycle analysis, and then take into account all the factors of plastic characterization, plastic depolymerization, pyrolysis, along with that the circular economy, and then develop their strategy. And so just to summarize, at the moment, companies are not that much bothered, but I see a future in which companies are going to be very much concerned.
And how about the regulation side? Are there any new developments with reference to the plastic waste?
Regulations are being developed. For example, the Environmental Protection Department has started a 1-year complete theoretical and experiment and survey-based study, based upon which they are going to strategize the plastic utilization in Pakistan and regulate the recycling industry based upon that strategy. Apart from them, UNDP is also conducting a survey in Pakistan, based upon which they are going to give suggestions. We at the Department of Polymer and Process Engineering are linked with the Environmental Protection Department, Punjab Food Department, Punjab Food Authority, and we are also are quite deeply involved with them in various legislation, along with giving them technical expertise. So slowly and steadily, these regulations and these strategies are going to be developed in the next few years, and then we will see their implementation in Pakistan too.
So, and I understand that from research, you're actively involved in the recycling aspect, particularly in the plastic waste. How is the plastic recycling, per se, the business-wise, plastic recyclers? Are they regulated or systematic?
Yeah. No, they are not regulated. They are not registered at any point. Only few. I can count those companies on my hands. Only few companies, 10 to 12, who are fully authorized, or you can say fully registered. Apart from that, it's basically a cottage industry in which people are conducting recycling in the basement of their houses, in old farmhouses, people are trying to manufacture various plastic products because they can't be regulated. Because if a company is converting hospital waste into food packaging, then that company needs to shut down.
Sure.
And the problem is not only in Pakistan, it is in Bangladesh, it is in India, even in China. They had to clamp down on these people very heavily, and even in Sri Lanka, Afghanistan. So everywhere these companies are available, they are recycling. I believe, I don't have the statistic, but having looked at the data that is available for worldwide and looking at the amount of plastic that ends up in our waste, our recycling ratio in Pakistan, India, Sri Lanka, Bangladesh, and China, it is on the higher 70%. India has conducted quite detailed study on it, and they are convinced that their recycling ratio is more than 60%. And I agree with that data, because we don't let anything go to waste. We try to consume it, but unfortunately, the products are not safe for the general public. So we are trying to motivate these recyclers and trying to convince them that they should come towards the solution that are not that can't come in direct contact with the food. But unfortunately, 70 to 80% of the commodity thermoplastic is being utilized in food applications. So trying to convince them that, okay, you are using, let's say, 50 tons of plastic waste at the moment, but if you listen to me, you will be using 5 tons of plastic waste for automotive and electronic applications, because the market is not that big. Packaging industry is huge. Utensils that they try to manufacture is huge. Even baby feeder bottle nipples, okay, even those are being manufactured from recycled waste in Asia. So trying to discourage them and trying to convince them would take quite a lot of effort. But companies are now listening to us. There are companies on board who are coming to us. I'm working on a project with Dr. Farhan Said. He's my co-PI, in which we are trying to manufacture these solutions and trying to transfer the knowledge to the industry now, because we believe now that the time has come where we work on research commercialization. Research commercialization is the need of the hour, and without it, no university can survive or no country can survive. The time has now come to move ahead from the research papers. Try to concentrate more on linking your research to the industry, and then trying to make sure that they are able to adopt your techniques and your. That is why we have developed different polymer pre-blending or pre-processing techniques, and most of them can be developed if the companies are willing to work with us, and now companies are coming towards us too.
That's nice. I see that you really put a real effort on recycling issues. Farhan, do you want to say something?
Yes, just to add on to Dr. Yasser. Actually, Param, the problem with the Pakistan is there are a lot of recyclers available in Pakistan. They are recycling the commodity thermoplastics and even engineering thermoplastic as well. But the problem is they are just focusing on the downcycling products. We are not upcycling the product, we are actually downcycling. So from the true circular economy point of view, we are removing the dollars from the economy of the world. So when we are downcycling our products, so the problem it's not only problem with the Pakistan, it's the problem with worldwide problem, that we are not going for upcycling. The actual circular economy comes when we go for the upcycling, and upcycling needs a lot of I think if we upcycle the thermoplastic, the cost of the recycled thermoplastic would be higher than the cost of the virgin thermoplastic, and that's the issue. And in some countries now they are forcing the manufacturers to add the recycled product at a higher cost as well, because government is legislating. They have some policies. If we don't have such policies, so we can't upcycle the product because no one would buy it from us. That's the big. I think it's a big hurdle that internationally there are not much policies available. Said you have to use 30%, you have to use 40% of your recycled plastic for a better circular economy. I think there's an international policy should be revised if we really want to go towards the circular economy.
It is a buzzword everywhere. First of all, okay, that's yeah. So everybody talks about it. It's always a challenge to be implementing that the circular economy. You know, packaging. We're talking about packaging waste. Of course, it has one challenge when it comes to the automotive and electronic waste. You guys have characterized the waste. You know, comparing the waste from the because you don't collect separately, it's all mixed up anyway. Okay, so how is the characterization of these waste, automotive and electronic waste versus the packaging waste?
At the moment, we are working on waste that is collected from personal protective equipment industries. We have in the past looked at some of the waste that was collected from the automotive industry, and there was only 10 to 20% deterioration in properties if it was manufactured from virgin polymer. Looking at the virgin polymer, we did collected some samples from our industrial supplier, and they gave us different samples that contain different amount of recycled plastics. So having analyzed their mechanical properties, you can say with virgin polymer, one cycle run and one complete life cycle reduces the properties by 10 to 30%. Those can be improved by utilizing effective pre-processing techniques and nanofillers. By adopting these two steps, we can then enhance their properties. There is now a concept in the world that where people are saying that we need to adopt the utilization of recycled plastic along with the virgin polymer side by side. Both production should start in the companies, because companies are very much reluctant to directly move towards a product that is based upon a high recycled content, okay? Because there are concerns for them from the consumer side, from their overall image, that they are using even cheaper plastic. So both the production can start simultaneously, and then slowly and steadily we can move towards a higher weight percentage of recycled. At the moment, the strategy is you replace some of your virgin polymer 10 to 20% with your recycled polymer, and then try to produce their blends. I see a future where we would have the reverse side, because the virgin polymer is not going to be available. Companies would not be manufacturing them. That side will be 80% recycled and 20% virgin. So whatever deterioration will be there in the polymer, that can be recovered with the help of virgin polymer along with nanofillers, if we are able to disperse and distribute them by using effective pre-blending techniques.
I think okay. You want to say
just to add, actually in Pakistan, there are more resources available to recycle the electronic waste rather than the automotive waste, because already automotive sector, they are using a lot of recycled plastic in their products, whereas the electronic market, they are using the mostly the virgin polymer for their products. So a recycler is looking for the first used plastic. So they are going towards the electronic waste, and they are getting the electronic waste easily. It's a hot market in Pakistan, whereas the for automotive recycled products, they are lesser, you can say, they are having some problems to recycle those products, because they are, some of the products are already having the recycled products, so the properties deteriorates too much. So that's why recyclers, they are hesitating in recycling the automotive parts as compared to electronics parts.
In electronics, you will also have more than not only plastics, but you also have valuable metals.
Yeah,
that's
valuable
huge,
exactly.
Yeah.
And there's one industry which is also extracting the gold from the electronics. Yeah, the chips, the which we are using. So it's a very hot market for recyclers as compared to the automotive sector.
Super. Okay, let's touch a little bit Dr. Umar. Hey, Dr. Umar. First of all, I really liked your presentation. You educated me a lot about how to harvest energy from sun, and it's really nice. Are there any solar panel manufacturers in Pakistan? You know, you guys talk about the PGEs, so that you can extract more solar energy, and we can rely less on the fossil fuels. Let me unmute. Can you unmute yourself? The screen got freezing. Uh-oh. Okay. Are you there? Can you unmute yourself, Dr. Omar? Okay.
Hello, Param, can you listen me? Because
yes,
I can't listen you because there is an internet problem. I did not listen even a single words from you. Please, can you repeat your question?
Okay, actually, I repeat, first of all, my compliments to you. It's really very informative presentation, and you actually opened my eyes. People should work on the solar energy more. How much energy you can extract, per square meter. You mentioned about 1,366 watts per square meter. Ooh, okay, a lot to explore, yeah. And can you, are there any solar panel manufacturers in Pakistan?
No, there is no manufacturing of any solar panel, any kind of solar panels in Pakistan. Basically, here we only assemble the solar panels. So there is no such kind of R&D. So there is no any research regarding solar energy or development of solar cell. So this is only a lab work. We are trying to propagate our research. And in the first slide, I mentioned that HEC is funded by this kind of research. So we are at the initial stage. Okay, in Pakistan, we are at initial stage. So we are basically fabricating thin film solar cells that not are just like of panels. So these small cells are being used in just like Internet of Things applications where you can
We lost the voice.
Yeah, I think he lost his connection again.
I think Param. You have Mar?
Okay, it looks like we lost his voice again. Connectivity issue. Yeah.
Exactly.
Yeah. So,
I think there is internet problem here. So So in summary, we are not fabricating any kind of solar panels. Just we are developing a material that can be used in thin film solar cells, particularly dye-sensitized solar cells.
Actually, your work is pretty good, and particularly because it increases efficiency. You have two case studies well presented with the fluorinated polymers and all the CNFs, and so keep doing good work, man. I really like that what you're doing. If you can save the world, if people utilize the.
Actually, there is a problem in efficiency. Efficiency is still very low. We are working on stability. We are successful in enhancing the stability, but we are still working on the efficiency. How to increase the efficiency? Because this is the main problem. Because when you charge the mobile, you need 2-volt battery, and we are not able to charge even a mobile at that time. But still, we are working. It is initial research.
Yeah.
But hopes
A
in future.
lot of potential is there, and also every government, every part of the world is focusing on the renewable energy. Polymers play a bigger role, if you wanted to increase the efficiency.
Yes. Now you in present day people are fabricating flexible solar cell in the form of sheets. So they are replacing silicon rigid metals with the plastic sheets. So they can even use a solar cell in the form of plastic sheet. That's a one major another advantage of polymer based solar cell. Silicon solar cells are very rigid. They need high temperature processing. But on the other hand, plastic solar cells are very flexible, and you can even use in the form of sheets. So that's another advantage. But there is a need of printing techniques, that is another problem. Fabrication is another problem. Testing is another problem. Fabrication is a big problem. So that's why, even to control the thickness of the film, that's another challenge. Because you can't use just just like in case of rubber, plastic, you can use high thick material even in millimeter or micrometer, but we need a thickness of nanometers. So thickness control is another challenge to get a good efficiency. So we need a CVD process, chemical vapor deposition process, plasma deposition process. So
We lost connection again.
His connection is gone again.
I think good idea. So solar cell, if we commercialize them, although we can't get better efficiency, but we can use it for multiple purposes. If we want to go on camping, we can go all our solar cell and we can take it. In those areas, we can get the electricity where we can't have the normal transmission electricity.
Actually, all the problems that what Dr. Umar has mentioned, of course, they're real, and I think as a researcher, that is the things that you have to work on, and of course we know the potential is there, and need is there. Potential is there, need is there, and I think that's researchers like Dr. Umar, to address all the challenges in their research work and develop solutions, and then only that. I think sustainability, all our lives, if we pollution wise, you see the solar energy can, you don't need any, you don't need to produce any emissions, right? So it really saves environment, it saves our future generations, and so what Dr. Umar work is very useful for the whole mankind. So yeah, so we're back. Okay.
Yes.
Okay, go on.
Connection problem.
Yeah, okay, it's all right. If you want any, what I'm saying is that, what your work is, is a very useful, important work, and all the challenges, what you mentioned, you need to find a solution as a researcher. Okay?
Yes, we are trying to get the solution of those problems. So that's we are applying for fundings in national as well as on international level. So we have got two fundings on this topic. So we are working on this issue.
So, Umar, it's all the best work, and really is very useful work. And as a polymers play a bigger role, in terms of the flexibility, in terms of the efficiency.
Yes. Yes. So I want to bridge these two fields. Yeah. Solar energy and polymers. Conductive polymers are very important, and they can play a very important role in flexible devices. As compared, they can replace the metals. So this is a advantage of polymer because they are lightweight.
Right. True.
That's they need low temperature processing.
Good. Thanks, Dr. Umar. Mudhir sir is here. Hi, Mudhir sir.
Yes, sir. I'm here.
Okay, you can open your camera, man.
Let me try.
Okay, yes. There. You're doing a MSc. This is your MSc project, research work, man.
Yes, sir. I presented briefly about my currently research work. It is in testing phase, so in upcoming webinar I might present my result. But right now it is in testing phase.
Okay, actually you're doing pretty good work. I see that you have done a lot of experimental work for mild blend method, dynamic injection molding, and solid state drawing. So are you connecting with this your nanofillers application into the circularity or recycling? How much really beneficial, or
Actually, what we are trying to achieve, we are incorporating nanofiller in recycled plastic to upcycle it. For example, we are currently working on the recycling of non-woven fabric waste, and we're trying to recycle into the product which can be used into automotive industry. So basically, we are trying to upcycle it our waste plastic.
Super, super. Good work. Keep doing good work. Keep doing good work. Okay, Dr. Farhan, any comments to your young researcher?
Yes, he's doing very good work. I think I like his point of view where he used the solid state drawing method to improve the properties of the carbon black fill isotactic polypropylene. I liked that particular point because normally different people, they don't think this point of view that just from this solid state drawing process we can improve the properties. And I think then he used the ultrasonic method for the dispersion of the fillers, nanofillers in the polymers. That's a very good, interesting area. Dr. Yase is very keen in working in that area to disperse the polymers using the ultrasonic method. So I think in future this technology would improve, and I think it would be available on the commercial scale as well. That we would have the ultrasonic equipments in our extruders for better dispersion of the nanofillers in the polymers, because there are a lot of work is going on in this area.
Super. Yeah, so good work, Mudhir sir. Keep doing. You have a long way to go. Okay, so I wish you the best.
Thank you.
So we are almost end to this session. So before we end it, I'd like to invite all the speakers to give final remarks to the audience. Okay, so may I go with Dr. Umar? I want to make sure you get connected quickly. So, yeah, Umar first. Final remarks.
Thank you so much, Param. This is wonderful events, and I am very thankful to you. You provided me a platform to present my research work, because there are, solar energy is very novel. There are a lot of very few seminars are available on this topic, but I am very thankful to you. You provided me a platform to present my work. And this is my first webinar in Pakistan on solar. When I was doing PhD, I presented my work number of times, but here there are very few chances to present my work. So I am very grateful to you. Thank you so much.
Thank you. Thank you. Actually, I had to thank you because you gave me an idea for me to do the next program, polymers for energy harvesting. This is going to be one of the themes in the future.
Yes, yes.
So
yes, please go ahead, and I think this is one of the wonderful area, and we should explore this area, because there is a lot of gap in between these two fields. So we should try to fill this gap.
Yeah.
Because future. Yeah.
Go on. Yeah, go on.
So no, but I just want to say one thing. Please, in future, you should organize another webinar on applications of polymer light harvesting applications, and another. Please also include that's use of polymers in energy storage applications. So that's are two major areas. So I think polymer can play a vital role in these two fields.
Sure.
So thanks once again.
You gave me an idea. I think it means that we need to work again together. Understand that?
Yes,
giving an ideas is one thing, and doing together is one thing. Okay.
Yes.
Okay. Okay. Thanks, man. Thanks, Dr. Umar, for your excellent contribution. Appreciate it. Yeah. Hassan,
thank you so
please.
much.
Unmute yourself, Hassan. You're unmuted. Yeah. Can you unmute yourself?
Can you hear me now?
Yeah, correct.
I just want to thank you, Piram, for inviting me for this talk. I have few comments that we should all collaborate in mutual areas, and we do a lot of research, and it goes in the waste, and we should collaborate more and more with the industry for implementing the idea we are doing at the academia. And the industry is mostly dependent on the trademarks, and they are not interested in our research. So just one comment for the industry to come close, and we will happy to introduce the product to your market. Thank you.
Sure, actually, I think you hit the nail right way, and it's true. Certain companies have, they don't approach not forward looking, working with universities, and there are a lot of good work is happening in universities like and it should be promoted. It should be publicized, and I think this is one of the reasons that the Pakistan Polymer Research Forum. It's not a webinar; it's kind of network together. And we should do on regular basis, so the more industries also, we can learn. So we create as a learning platform for not just only Pakistan industry or Pakistan researcher, but it's a kind of platform for Pakistan and outside of Pakistan as well. So your point is very valid. I think we need to put the hands again together and do good for the industry and automatically it impacts up in whole world, in whole economy, everybody's lives. I think that's so, thanks Hassan for being part of this Pakistan Polymer Research Forum. Keep doing good work, and I look forward to see you again in the next program soon or later. Okay, so
Thank you.
Thanks.
Thank you.
Mudasar, hi Mudasar, young man.
I would like to thank you and Mr. Hamid Iftikhar for organizing this webinar. And I would like to thank my supervisor, Dr. Yasir Kyungil, and all my respected teachers. And I would like to add one more thing that I would suggest to upcoming researcher to explore non-woven plastic waste, because it has grown exponentially during the recent COVID waste. Also,
Yes.
there is a ban on shopping bags, which also driving the non-woven fabric production. So it's a relatively new field and should be explored by upcoming researchers.
Yeah, sure. That is of course, that is a perennial problem, plastic waste. It's we've been talking probably from I don't want to say how much, but very long. Okay, but we still experience, we're still finding new solutions as well. Okay, and more, I think the plastic waste is we're getting more value added products, and I think Dr. Farhan is mentioning upcycling. Okay, that is key also. Okay, so it is we will doing more and more on this, because at the end of the day, the problem is the mindset of the people. As long as they don't throw it away, okay, they manage it properly, then no problem. People look down. Plastic is a beautiful material, and it solves many problems. And during the COVID times, if there is no plastic, can you imagine how it's going to be life, right? Okay,
Yeah.
So it is an important material. It's just a matter of the systematically manage it and utilize it properly. That's and of course the upcycling and recycling. These both are very important role they play in our journey. Sure, it is a continuous topic we will be adding. Dr. Yasir, thank you very much, sir. Appreciate your participation.
Thank you. Thank
Please.
you, sir.
Okay, I would like to thank Piram and Amit for giving me this opportunity. I was the presenter in the first Pakistan Polymer Research Forum. I'm presenting now. So being an experienced member, I would like to suggest that in the future, along with deciding that, okay, this should be our date, we need to decide the thematic areas.
Yeah.
2 to 3 thematic areas. If they are decided, then arrangement will be much more easier for myself and for Mr. Farhan Said and Dr. Umar Mahmood and other fellows. They can then ask their students to come and present their work in these talks. So, because everyone, when I used to ask them on behalf of Hamid Iftikhar to come and present over here, the question was, what is the theme about? Okay, when I try to say that it's just general, then the interest would lose. They would lose their interest very rapidly. So if we define some thematic areas and plan ahead for the next 3 Polymer Research Forum, that okay, This one is going to come in September. This is going to come in December, and this is going to come in April or May. We have 3 polymer research forums planned for next 3 times, and we have the areas defined for you. You don't want to present in this one, come into the next one if your area is available. So based upon that, we can build up a much higher audience for these polymer research forums, and it would be much more effective for us because in the next one, as I told you in the last polymer research forum, that if we are going to move towards, let's say, polymer recycling specific research forum, then I can invite some local government officials and they can come and present their work. The research, they are also doing research. So, but they need to know that what is the theme area, what is going to be the audience, what other participants are going to be there. So once we say it is going to be general, the interest they just lose all their interest.
I do agree, totally agree. You have mentioned the same thing last time also, actually, and it's in the process of building up. And as I was mentioning to Hamid, we will make it on a quarterly basis so that we can, having this session, many speakers also challenging. Next one we will be in next 3 months time, but we will definitely do. I think your point is well taken, and totally agree with you. Now we have the increasing the frequency so that we can focus on the themes, on specific theme for each editions. And so I do agree with you, Asir. Appreciate. And I recall you mentioned it last time in December. Okay, number. Okay, so we will be making a change in the next edition. Amit, you haven't had any comment there?
Yes, Yasir has mentioned it very rightly, and it must be done. But let me tell you something about it. Last time was our first event, the Pakistan Polymer Research Forum. And I think I shared with all of you, especially Yasir and Param, shared with both of you that I faced a lot of difficulties. I mean, if someone asks me to present my work, it's my right whether I agree or not. Even if I do not agree, I should be courteously refusing to that. But I faced a lot of people last time who did not even bother to reply me, who did not even bother to respond me. So I was kind of very heartbroken at that time. And in that situation, I don't think one can plan to specify the topics and then invite the guests, because for the general discussion, people were not showing interest. So if we specify the topics, so we'll have the limited speakers. So, but this time, the major change from last time, what I saw this time, that people themselves were willing to participate in this event. There were a couple of people who were willing to participate in this event, but coincidentally, they had some other commitments for today, so they excused me for that. Otherwise, at least one of them could have been a part of this talk today. So now, when I'm getting this kind of response from people, now we can work on this particular aspect, that we specify the topics and then invite the people. So we'll definitely, Yasir, consider this. I'll talk with Param after the event about it, and we'll definitely take you and Dr. Farhan in loop as well, because I would specifically mention something. I would specifically like to mention something about Yasir. I mean, he's the one who stood with me in the last event and in this one as well. I mean, after me, if someone supported me to make this happen last time and this time as well, he was Mr. Yasir. So I really appreciate it.
Yeah, thank you very much, Dr. Asir. I wish that we will meet some days in person, but I see you gave us good encouragement, and one of the focus of this program is we want to build a network of polymer people. Okay, once we build a network, we know this WhatsApp group is there. I'm asking all your people, please add all the polymer related people. Okay, we can meet on the regular basis through this platform, and because they have any issues we can discuss as well. So we make it I think I already mentioned to Hamid that we had to do every 3 months one time, so that on focus theme, as you rightly mentioned, it is very important to focus a theme. Just like Umar is wondering also, hey, I'm a totally outside guy. I'm a polymer in energy harvesting. Other guys talking about polymer processing. Well taken. I totally agree with you. Okay, so let's make a better one. I think we made 2 steps already. I'm really excited and also motivated with your input. That hey, we got to do more. We had to take all your suggestions. So. Thanks once again, Dr. Asir, for your input, and you will see change in the next edition. Okay, and I'd like you to be part of and continuous support as well, just as mentioned, Hamid. Okay.
Yes, I will be there.
Dr. Farhan, would like to hear your words, final words.
Thank you, Pam. I think it was a very good networking session. Everybody had a lot of things to say, and there was good suggestion from Yasser and Hamid. And there's only one point of view from my side. I think we should keep it short. A lot of people don't attend it because it's a big, longer session. No one is somebody having a holiday or it's a weekend, as well. So they can't spare the 2 and 3 hours in a row. So if we just make it crisp for 1 hour, 1.5 hours, I think we should have a better audience and we have a better, more attendees group. So this is the main thing in future. That definitely we take a small step, baby steps when we go for a bigger goal. So you took these 2 initial steps, and these are very successful. And I think I wish you good luck for the future, and I would be a part of your sessions in future as well. But I think for a better interaction, it should be 1 hour, 1.5 hour sessions, maybe frequent sessions as well, more frequent, so we can have a better audience and better interaction. But overall, from networking point of view, I think it's a very good platform. It's a good platform for us, all of us, and there's a huge input from your side, Param, from the from Yasser. In fact, Yasser was the guy who convinced me to present, and he himself gave the topic of my presentation. I think a lot of credit goes to Yasser and Hamid for arranging this event. Yeah. Thank you, Param.
Thank you, Farhan. Actually, yes, I do agree on this. The length of the program, it's always a challenge about time. Okay, and this program, it gets recorded. We will place on YouTube or public for public platform, and let the people to watch it whenever there is convenient. Also, their option is there. I think I take your point well taken that when a crisp program and up to 90 minutes or less than 2 hours would be better. Okay, and maybe frequent. Well, it's all the challenge about how frequent we can do, but let's go with the quarterly now. Okay, that is the last time we talk about. Actually, first time I did was yearly. After that, I said, okay, let's do the biannual, for 6 months one time. And Hamid, okay, let's give it a try. I think after seeing the taking the input even Dr. Asir was he was telling me about focus. When you want to focus, you need to increase the frequency, so that we can focus either polymer recycling or the tire recycling, or even you can break down into rubber and plastics. It can be divided in totally also. Okay, so thank you very much. All the suggestions and input on that. Hamid, final words as a co-host.
Yeah, just like I mentioned before, that last time I was literally quite disappointed on the response of people I contacted
and Dr. Farhan and Dr. Yasir know a lot of those people, but I won't name them here. But this time, let's not discuss about past. This time, I really appreciate this one, and I really appreciate the fact that people themselves contacted me when I posted it on my WhatsApp status and LinkedIn. They themselves contacted me, and they were willing to participate. And as I told you that a couple of those people, they had some other commitments today, otherwise they could have also joined. So now when we have
Lost a voice. Maybe we lost your voice. Okay, yeah, okay, guys. Actually, I always say I've been organizing a program for last 18 years. I don't know how many, probably a couple of hundreds or maybe close to 1,000. I don't know. I cannot number it. Okay, Amit back. Yeah, your voice gone. Yeah.
can you hear me now?
Yeah, I can hear you. Yeah.
Yeah, I was just telling that people are now themselves willing to participate in this event. So as you have suggested, we can now definitely specify the topic because we have now more number of speakers. So specifying the topic makes sense now. So we'll definitely work on it and proceed accordingly.
We build this program, okay, on the this polymer research groups through the Pakistan Polymer Research Forum. So let's continue to build it, okay. And thank you all for joining this session. And if you missed this whole presentations, you can check on YouTube at the TechnoBiz channel. I think in the next 24 hours I will be uploading, and all the discussions also will be part of it. Okay. I already planned for the next schedule, okay. But then before that, if you are interested to contact any of us, either me or Hamid, this is the contact information. You can check it. For additional support or assistance you need, you can reach out to us. The next edition will be on the 27th August. Where the theme will be finalized and the theme will be announced, so that Hamid will be we will be in touch with all of you. Okay. Thank you all for joining this session. Namaskar. Thank you very much.